Okay. So today we are going to cover our last part ng chapter 5. Okay? So tapusin natin 'yon today, madali lang naman 'yon. Then by Thursday, Friday, so this is applicable to my lab classes, no? So manonood din kasi sila ng session natin because asynchronous sila, no? Because of the integrity day yesterday. Okay. So since async sila, record ko na rin. Okay. So yan, so today discuss natin yung last part. Then by Thursday, Friday, Saturday, okay. So you have a 3-day allowance. Maybe let's make it 4. So from Thursday to Sunday, okay. So around this period, i-open ko yung 2 quizzes for the chapter 5, okay. So again, open ko yung dalawang quiz for chapter 5 within this period, Thursday to Sunday. Okay? 2 attempts 'yon. Okay? So ibig sabihin pag mababa points ng una, piliin niyo na lang uli yung better answer. Okay? So 2 attempts per quiz, and then they will be open starting Thursday to Sunday. Wala tayong class this day, Thursday, Friday. 'Di ba sabi ko tuloy-tuloy tayo? Dalawa kasi yung quiz, no? So to give you more time, edi wag na lang tayo magklase, no? Okay, kawawa naman tayo eh. Okay, so yun lang. So after dalawang quiz, back to isa-isang quiz na lang naman ulit tayo. Okay? So yun yung schedule natin. Again, tapusin natin yung chapter 5 today. Then on Thursday, Friday, Saturday, Sunday, there will be 2 quizzes assigned to you. You will be given 2 attempts, no? So that you will have more chances of getting high scores. Okay? Onting items lang naman yung quiz, don't worry. Siguro isang quiz 10 items na. Instead of 20 items. No? Kasi since medyo calculation intensive siya, there will be much higher points for difficult questions. No? So, ganun mangyayari. Ayan. So, again, dito tayo, dalawang quiz. Then, by next week, we will start with the chapter 6, which is on electrochemistry. Medyo mahaba din 'yon. Okay? So, I'm expecting dalawang session tayo, dalawang weeks tayo doon. So, maybe ang schedule natin for electrochem will be 26, 27, first lecture. Then, on 29-30, second lecture. And then, on 3-4, third lecture. And then, 6-7, possible quiz day yan. Okay. Then, ay, teka lang. Bakit? Kasi ito pala yung natin. Ito na yung end ng SEM. Final exam week nga pala to. Okay. So, siguro bawasan ko na lang yung coverage ng electrochem. Dali lang naman siya. Okay. Kailan po possible final? Ang final exam kasi according to the school calendar is ito, 17 to 22. Wala silang announcement about adjustment eh. So it means that the earlier announced schedule will push through. Okay. So the final exam is May 17 to 22. Okay, so I think medyo bibilisan na lang natin after ng titration talaga. Okay. Madali lang naman yung last 2 topics, no? Sir, pwede po bang paulit ng mga dates para sa mga quizzes? Okay. So, medyo dadalian ko na ng topic. Siguro, ito. For chapter 5 quiz, dalawa kasi yon. So, medyo mabigat. Ito yon. 22 to 25. Okay. Chapter 5 quiz. Part 1, Part 2. And siguro 10 items yon. Then, may 2 points each. May 3 points each. No? Depende sa question. Okay. So, ganun yung mangyayari sa atin. And then you will have chapter 6. Discuss natin yung next week. Okay. So, kung kaya natin tapusin yung chapter 6 in 1 week, siguro kaya naman, no? Basic calculation lang naman yun, to be honest, no? So, kaya yan siguro. Okay. Then, we will have yung chapter 6 quiz, most likely dito siya lalabas. Okay. So, on the 19th week of the year. Okay. So, somewhere here, 3 to 8. Okay. And then, yung quizzes natin for the last two topics, no, which is on spectroscopy and separations possible. Both sila mag-appear on 10th to 15 week. Pwede rin ako mag-assign sa 17 to 22 na week, no? Para hindi masyado hassle. Pero madali lang talaga yung topics na yun, no? About colors lang siya. Okay. So, yan. So, papamigay ko na yan sa inyo eh. Okay. Ayan. Medyo medyo magkakram tayo dito ha. Medyo lang naman, no. Okay. Pero kaya yan. Okay. Basta yun again, final exam nyo for all the classes will be 17 to 22. So, most likely sabay-sabay uli yan, just like last time. Okay. So, yan. So, good luck, no. For Anachem naman, ang focus talaga for the finals is titration and then electrochem. Yun talaga yung primary focus sa exams. Okay. Okay. So with that, yan yung calendar natin. Hopefully, ma-note nyo yun. The final exam schedule is true for all subjects. No? Kasi yun yung nasa university calendar natin. Okay, so let's continue our session. So we ended up with the diprotic base, the polyprotic titration curves, okay? So medyo alam nyo na how to interpret the curves, no? So for example, if you consume 10 ml to reach this endpoint, how much volume pa ang kailangan to reach the second endpoint? The same lang, okay? So if you consume 10 ml to get to the first endpoint, you need to have another 10 ml to reach the second endpoint. Okay? So, important yon sa i-discuss natin today, which is on acid mixtures and base mixture titration, especially sa base mixture titration. Okay? So, yan. So, pwede kasi when we are titrating stuff, no? When we are titrating acids and bases, pwedeng magkahalo yung dalawang acid, pwedeng magkahalo yung dalawang base, no? Okay? So, pwede ganun yung mangyari. So, depending on the behavior of your acids and your base, no? Pwedeng yung isa muna ay matapos sa titration to be followed yung isa pang molecule. Okay? So, kunwari, yung strong acid muna yung matatitrate followed by the weak acid. Ganun yung process eh. Yung mga strong muna yung matatitrate followed by the weaker ones. Okay? So, ito lang yung mga pointers that we need to know. If you have two strong acids in your solution, let's say HCl and then HCl and then isang strong acid natin. Kunwari, let's have HI, okay, or HF, no? So if you have those two strong acids, then they will be both titrated at the same endpoint, okay? Pares silang matatitrate to the same endpoint, okay? Kapag may mixture ka naman ng dalawang weak acid, okay? So they can be titrated separately, okay? Makikita mo yung difference sa kanilang inflection points when the difference in their Ka values are 1,000 or above. However, this is uncommon. Medyo uncommon to. Okay? So, ayun lang. Pero if they have near values for the Ka, then possible that their inflection curve may overlap. Okay? So, pwedeng iisa lang din yung maging endpoint nila. That is if their their Ka values are near to each other, pwede sila mag-overlap, no? Yan. For example, ito. So, yan. So, kunwari, ito yung isang weak acid, ito yung isa pang weak acid. Okay. So, their endpoints may overlap if the Ka difference is not so big, no? Okay, so less than 10 raised to the 4 factor. Okay. However, if their Ka difference is big enough, no? Pag medyo malaki yung Ka difference nila, then you will observe different endpoints, no? Okay. So for example, yan yung isa followed by yung isa. Ay, ayusin ko yung curve ko. Okay. So kunwari yan yung una, then followed by the other weak acid, no? Yan. So kapag magkaiba yung kanilang pag malaki yung difference ng kanilang Ka, then you may observe 2 endpoints na. However, if maliit lang difference ng kanilang Ka, then they may have 1 endpoint only. However, this is uncommon. Uncommon to. Okay? So yan. Strong acid plus monoprotic acid. Okay? So it will give you separate endpoint. Okay? Take note that okay, so separate endpoint yan, of course. Okay, so unang matatitrate is the strong acid followed by the weak acid, no? So, same concept just as this one lang din. Okay? So, yan, always yung strong yung matatitrate followed by the weak. Okay, yung weak yung nahuhuli kasi parati talaga. Okay, so ibig sabihin nun, iba yung endpoint for the strong, iba din yung endpoint for the weak, no? Then lastly, if you have a strong acid, and diprotic acid, ayan. Yung first equivalence point nila, parehas matatitrate yung strong acid and the first dissociation. And then on the second endpoint, yung neutralize na lang doon would be the second dissociation of the acid. No? So let us visualize that. Kunwari HCl and H2SO4. Okay, kunwari ito yung ating acid. So the first dissociation would be HCl to salt. Okay. Yan yung sa strong acid. For the sulfuric acid, ang first dissociation niya ay H2SO4 to HSO4. Okay. So sabay ito mangyayari. Yung formation of salt from the strong acid and the formation of bisulfate from sulfuric acid. So ito yung first endpoint. Then on the second endpoint, yung another acid na lang yung matatitrate ulit. No? Okay, so stepwise yung titration kapag diprotic acids. Okay, so ganun lang yung idea niya. Basically, yung curve lang yung magbabago. Okay, so yan. So wala tayong masyadong example for this one. No? Isa lang yung bibigay kong example because again, acid mixture is uncommon. No? Hindi naman to masyado ginagamit talaga. Okay. Kaya, onting problem lang bibigay ko sa inyo. Dito tayo sa base mixture, medyo maraming application. Okay? So, the common problem for you is this one. Okay? So, possible kapag lumabas to sa quiz, yung numbers lang babaguhin ko, no? Okay? Kasi onti lang talaga yung question regarding this, no? Di ko siya na-encounter madalas. So, possible na yung numbers na lang baguhin ko. That means the process will be the same all throughout. Ganoon naman kasi ginagawa namin sa exams niya. Okay? So, for example, you have a mixture of HCl and maleic acid. Okay? So, if you have a mixture of HCl and maleic acid, and it is titrated with sodium hydroxide, no? So, paano natin i-draw yung titration process doon? So, for strong acid, yung endpoint niya would be this one. No? So, HCl manoneutralize to water na lang and the salt. No? So, isang step lang yan and this will give one endpoint. Okay? But for maleic acid, no, this is a strong, let's say weak acid, weak diprotic acid. Okay? So, ano mangyayari doon? So, dalawang steps yung dissociation ng H doon, di ba? So, you have the first dissociation of the H and then the second dissociation of the H. Okay? So, the first dissociation will overlap with the endpoint of the strong acid, no, it will overlap. Okay. So, parehas yun mangyayari. Titration ng strong acid and the first dissociation of the weak acid. Okay. Then, ang susunod doon will be the second endpoint, no, which is the neutralization of the second dissociation of the weak diprotic acid. Okay. So, yun yung idea uli. Again, ulitin natin ano nangyari. Weak diprotic acid, WDA. So, anong mangyayari uli? So, sa first endpoint, dalawa yung mangyayari. Yung neutralization of strong acid and then the first dissociation of the diprotic acid. No? So, yun yung mangyayari at the first endpoint. Then, on the second endpoint, isa na lang yung mangyayari. Yung neutralization of the diprotic acid. Okay, the final neutralization, yung second step niya. Okay? So, ano implication nun? Kasi dalawa nangyari sa first endpoint, isa lang nangyari on the second endpoint. Ano implication nun sa atin? The implication is that mas maraming titrant magagamit dito compared to this one. Okay? Bakit maraming titrant magagamit dito sa first endpoint kaysa sa second endpoint? Kasi nga, dalawa yung niruneutralize mo. The strong acid and the first dissociation. Okay? So, yun yung konsepto dito. Pag dalawa yung process na nangyayari sa'yo, more titrants magagamit mo. So, that's why sabi dito, the first endpoint occurs at 25 ml. Compare mo yan sa second endpoint, which occurs 10 ml after that. No? Okay? So, ibig sabihin, again, kapag dalawang process yung nangyayari, mas maraming titrant magagamit mo doon. Okay? Mas maraming titrant kapag mas maraming process yung ninoneutralize. Okay? Then, since isa na lang for the second endpoint, onting titrant na lang gagamitin mo. Okay? So, yun lang yung overall idea dito. Okay? So, yan. So, paano natin malalaman yung millimoles of HCl and maleic acid given all this info? Okay? So, paano natin malalaman yung dami ng HCl and the maleic acid from all this info given? Okay? Ganito lang. Okay. Di ba sabi ko sa inyo, if you have a diprotic acid, ang volume needed to titrate the first endpoint will be equal to the volume needed to titrate the second endpoint. Okay? So, ibig sabihin kung ano to, kung yung kung yung second endpoint ay 5 ml, the volume needed to titrate the first endpoint will be also 5 ml. Okay? Kasi equal yun kapag diprotic acids, 'di ba? Kung 5 ml ka sa second endpoint, that means 5 ml ka uli sa first endpoint. Okay? So from this diagram I showed here, no. So kung 10 ml tong second endpoint for this diprotic acid, how much ml yung first endpoint niya? Ilan yung magagamit niya sa first endpoint? That should also be 10 ml. Okay? So that means kailangan mo ng 10 ml titrant to reach the second endpoint. So ibig sabihin nun, the first endpoint should also use 10 ml only. Okay. Bakit siya naging 25 dito? Okay. Bakit siya naging 25? Kasi sabi ko nga, dalawa yung tinatitrate mo. Since you know that 10 ml of this ay ginamit to neutralize this one, that means the remaining 15 ml is needed to neutralize the strong acid. Okay? So again, ano nangyari? Ano nangyari? Ganito yung idea ulit. Redraw ko lang yung sinulat ko ulit kanina. Alam natin, sabihin ko, we know that for diprotic acids, no? Ito yung itsura ng curve niya. Okay, so we know that for diprotic acids, kung ilang ml yung first endpoint, ganun din dapat yung ml ng second endpoint. No? So in our problem, the volume needed to reach the second endpoint is 10 ml. Okay, second to. Okay, so the volume needed to reach the second endpoint is 10 ml na lang. That means yung volume needed to neutralize the first endpoint is 10 ml also. Kaya sinabi ko doon, kung 10 ml to, dapat 10 ml to. Di ba? So, ibig sabihin, yung sobra nito is needed to neutralize the strong acid. Okay? So, ngayon, alam na natin gaano karaming titrant yung nag-react sa diprotic acids natin and sa strong acid. No? So, ngayon, alam na natin how much of the titrant is used to neutralize the diprotic acid and the strong acid. Okay? O, alam na natin. Okay? Kung medyo blurry, sabihin lang. No? Pero yun yung idea. Kung 10 ml to, that means 10 ml yon. Okay? So, ang sobra dun sa 25 ml is ginamit to neutralize the strong acid. Okay? So, yun lang yung concept dito. Kung gaano karami na ubos dito, yun din yon. Then, yung sobra dito, sa strong acid yan. Okay? Yung sobra parati binibigay kay strong acid. No? Okay? So, yun. Bali, ang priority nyo, kunwari, makakita kayo ng ganitong question, same process lang naman, no? Kunwari, makakita kayo ng ganitong question sa quiz natin. Isipin nyo na lang, kunwari, sinabi dito, second endpoint is 5 ml. Ibig sabihin, the first endpoint for diprotic acid is also 5 ml. Okay? Then, kung ano man yung sobra dito sa first endpoint, kay strong acid na yan. Okay? So, kunwari, 5 ml to, that means ito, 20 ml. Okay? So, ganun lang yung idea dito. Okay, bakit again magkaiba yung endpoints nila? Kasi meron tayong strong acid and diprotic acid, no? So, dalawa endpoints talaga ng diprotic acid, kaya dalawang endpoint yung ma-observe natin. Okay? So, medyo marami lang yung magagamit na titrant to reach the first endpoint kasi nga, dalawang processes yung nangyayari. Kailangan mo i-neutralize ito, pati ito. On the second endpoint, onti na lang kasi ito na lang kailangan mo i-neutralize. Okay? So, yan. So, alam na natin that 15 ml of the titrant is needed to neutralize the strong acid. Okay? So, ito ay 15. Ito ay 10. Ito ay 10. So, 15 ml to neutralize the strong acid. And overall, 20 ml to neutralize the weak diprotic acid. Okay? So, since alam natin yung dami ng titrant used, no, to neutralize our acids, no. Ibig sabihin, pwede na natin malaman yung moles nila. Okay? Pwede na natin malaman moles nila. How? You know that mole titrant equals mole analyte naman, di ba? Okay? So, gagawin mo, ipa-plug in mo na lang yung 15 ml ng titrant, multiply mo sa molarity ng titrant, you will get the moles of the titrant which is equivalent to the moles of the analyte na. Okay? So, ayan. Ganun na lang ang gagawin mo. Alamin mo lang yung total volume of the titrant needed to neutralize this and this. Pag nalaman mo na yung total volume to neutralize them, you multiply it by their molarity to get the moles. No? Yun, tapos na yung problem. Okay. So, kailangan lang you design a correct pattern. Okay. So, itong diagram na to, binigay ko nun to sa inyo so that pag nakita nyo to uli sa quiz, alam nyo na gagawin nyo. Papalitan mo na lang yung ml nila. Kunwari, sabihin natin 30 ml to, tapos ito ay let's say 7 ml. Ito example lang kunwari, 30 ml yung first endpoint, the second endpoint is 7 ml. So, ibig sabihin nun, 7 ml to, 7 ml yon. Yung sobra na 23 ml dito sa first endpoint kay HCl yan. Okay? So, that means you need 23 ml for this, 14 ml for this. Okay. Yung 23 ml pati yung 14 ml, i-multiply nyo yan sa mole of the titrant. Okay? So, ganun na lang gagawin nyo. Kaya may diagram na akong binigay. Anyway, so going back to the problem. Okay. So, this will be 15, 10, and 10 according to our analogy. Okay. So, since we now know the mole of the titrant needed to neutralize the strong acid and the weak diprotic acid, then we can now solve for their moles using the equivalence equation I gave you last time. Okay? So, pwede na natin to gamitin to get their moles, no? Yung moles nila. Okay? However, before we proceed with that, no? Before we proceed with that, no? Let me lang correct myself, no? Last time. Ito medyo important to. I have a correction sa sinabi ko before sa inyo. 'Di ba sabi ko for monoprotic, okay, NT equals NA, which is true naman. Okay? True yan. Walang magbabago dito. Kasi the ratio of the two substances ay 1 to 1. Okay? However, ang correction ko doon is for the diprotic and the polyprotic. No? Bakit ako nagkaroon ng correction? Nagkamali ako ng tingin sa notes ko eh. Okay. So may notes din kasi ako na ginagamit. Yun yung yun yung review center notes ko, pati yung undergrad notes ko. So nagkamali ako ng kopya kasi, no. So I'm sorry for that. I'm very sorry. Okay. So doon ako nagkamali sa diprotic and triprotic acid. Bakit? Ano sabi ko last time, no? 'Di ba sabi ko for example, 2 moles yan, eh dilalagay mo 2, di ba? However, in reality, it should be a fraction, not a whole number. Instead of writing 2, it must be 1/2. So that means for triprotic then, ibig sabihin nun, instead of writing 3, it should be 1/3, no? So yun yung na-oversight ko. I'm sorry for that. Okay, kino-correct ko na siya ngayon pa lang para maayos natin yung mga bagay. Okay. So I'm sorry for that. Okay. Pero let's explain bakit siya naging fraction instead of an integer. Kasi parang it seems na tama yung sinabi ko last time, no. Yun nga, na deceived din ako noon kasi nagkamali ako ng tingin sa notes, no. Okay. Pero ito yung real explanation why fraction dapat instead of a whole number. Okay. So ano yung explanation for that? Okay. So let me erase this part muna. Paki-note na lang pasensya na guys. Ayan. Tagal ko na kasing hindi na balikan tong anak. Okay. So let me correct myself with that. Bakit siya nagiging fraction? Bakit hindi siya whole number? In contrast to what I said last time. Okay, so suppose we have diprotic acid reacting with 2 moles of KOH, no? Okay, so neutral na yan after. So, bali ganito. So, if you will recall stoichiometry, if you want to convert the mole of KOH to mole of the H2A, kung gusto mo i-convert yan to mole of the H2A, ano gagawin mo? You multiply KOH by the stoich factor. You multiply it by the stoich factor. Paano natin sinusulat yung stoich factor? Nasa baba yung gusto mo i-cancel, which is mole KOH. Nasa taas yung mole ng gusto mo makuha, which is H2A. So, writing the coefficients for H2A, that is 1. For KOH, that is 2. So, that's why dapat 1/2 yon instead of 2. Okay? Kung sino yung may coefficient, siya yung may 1/2 na katabi in terms of moles. Okay? So, ito yung dito ako nagkamali, guys. No? So, pasensya na. Okay. So, I did the wrong stoich. No? So, again, kapag diprotic acid, instead of writing 2 as the number here besides KOH, dapat 1/2. So, imagine nyo, fraction parati dapat because of the stoich factor. Okay? Kailangan kasi makancel to. Kaya nasa baba dapat siya. Yung coefficients. Okay? So, for triprotic acid, ganun din yung konsepto. Okay? So, let me erase this. Ba tayo mabura? Ayan. So, let me erase this. For triprotic acid, ganun din yung konsepto. Let's say you have H3PO4 reacting with 3 moles of KOH. Neutral. Okay? Neutralize na yan. So it should be written as 1/3 mole of KOH. No? So instead of writing 3, dapat 1/3. No? Why? No? Kasi if we will convert the mole of KOH, no, with the correct stoic factor this time, nasa baba yung mole ng KOH, nasa taas yung mole ng H3PO4. Okay? And this will give us the mole of H3PO4. That's why kailangan 1/3 mole ng KOH ang equal sa mole of H3PO4. Okay? So yun. So instead of writing the whole number, we write the fraction instead. Okay? So we write the fraction. So yun lang naman yung correction ko, no? So ibig sabihin for diprotic acid, instead of 2, kailangan 1/2 yung ilalagay mo sa species with a coefficient 2. Kapag triprotic acid naman, instead of writing 3 dun sa species with a coefficient 3, kailangan 1/3 ilalagay mo. Okay? So again, I'm sorry for that, no? If that causes any problems, pero ayun na nga, kinorek ko na siya beforehand para tumama na yung sagot natin. Pasensya na ha. Ang last na tingin ko pa kasi sa Anachem is 2019, 2020. Okay? So, puro Gen Chem kasi tinuro ko na din last time. Okay, so ni-refresh ko na lang siya noong tumingin ako ng notes. Naghanap ako ng problem sa notebook ko. Sabi ko, ay na-discuss ko na tong problem na to. Tapos nung dumating na ako sa diprotic, sabi ko, hala, bakit fraction dito? Yun yung unang reaction ko. Hala, bakit fraction to? Ba't hindi siya whole number? Tapos nireview ko yung stoic. Sabi ko, ay mali ako, sorry. So yan pasensya na guys, no? Even ako nagkakamali din, no? Kahit may kahit professional ka na, kahit may laude ka pa, no? Pwede ka talaga magkamali. So sorry guys, ha? So kino-correct ko na siya, no? Para sa inyo. Okay, so again, for monoprotic, 1-to-1 yan. So wala tayong issue doon. For diprotic, doon na lumalabas yung fraction. Na equals NB. For triprotic, for tripo, 1/3. Okay? Na equals NB. Okay? So kung sino yung may coefficient, siya yung may fractional na katabi sa moles. Okay? So yan lang. Okay? So let's go back to our problem. So sabi natin HCl required 15 ml for it to be neutralized. The weak diprotic acid required 20 ml for it to be neutralized. So to get the moles of HCl, easy lang yan. Monoprotic lang to. So we say mole HCl equals mole of the sodium hydroxide titrant. 1-to-1 lang naman yan, so wala tayong problem with the numbers in front of the moles, no? So, ba't ba napupunta sa next slide? Ano ba yan? Okay. So, we write the moles of the sodium hydroxide as the molarity sodium hydroxide times the volume of NaO. Okay? And that will give us the mole HCl then. Okay? So, yan. So, what's the molarity? 0.1 molar times the volume, 15 ml. So if we multiply molarity by the volume in ml, we will get millimoles, no? So ilang millimoles yan? 1.5 millimoles HCl. So ito yung composition ng ating mixture. Ito yung composition ng ating mixture, no? So we have 1.5 millimoles of HCl in the mixture. Okay, so yan. So we have 1.5 millimoles of HCl in the mixture. Okay? So, ganun lang. Ipa-plug in mo lang siya dito sa equivalence equation natin. O let's call this equivalence equation, ha? So just plug in the molarity of the titrant, volume of the titrant, since you know that 1 mole of this is equivalent to 1 mole of this, no? Plug in, you get the mole HCl equals to 1.5 millimoles. Yan na, tapos na, di ba? Parang ang lang niya, no, ang intimidating at first kasi ang dami nangyayari. Pero pag kinalculate mo na, madali lang talaga siya. Okay? So, ganyan lang. Tuloy-tuloy mo lang. Okay? So, yan. So, yan. How about the weak diprotic acid? For the weak diprotic acid, ano? For the weak diprotic acid, naburahin ko na to. So, NH2M, sino yung may 1/2? Yung H2M o yung NaO? Sino nga ba? Let's write the balance equation para alam natin kanino ilalagay yung 1/2. Okay? So, if you neutralize H2M with NaO, papansin nyo, isa lang yung OH na to, ito dalawa yung H. Di ba kailangan dalawang OH pag dalawa yung H? So, yung NaO, yung may coefficient na 2. Okay? Pag binalance mo correctly yung equation. So, since may 2 yung NaO, dapat may 1/2 dito kay NaO. Again, 1/2, hindi na siya 2 lang. Okay? So, yan. So, kinorek ko na sarili ko kanina. And-explain ko na kung bakit 1/2 yan instead of 2. Okay? So, we should be clear at this point na. Okay? So, yun lang. You balance it correctly. No? So, since dalawa H na to, isa OH nun, ibig sabihin, dalawang OH kailangan dapat dito. So, multiply mo lang yan by 2. So, if you write it in our equivalence equation, instead of writing the whole number 2, it should be 1/2. Okay. So, yung NaO, yung may 1/2. Okay? Tama na yan this time. Okay? So, let's solve for the moles of the H2M, the maleic acid. So, that will be 1/2 molarity NaO, volume NaO. Okay? And then plug in all the given 1/2, 0.1 molar, and then we have 20 ml. So, ilan yung moles ng maleic acid using the formula? Okay, so that will be 1 millimole. Okay. Okay, so that means our mixture is composed of 1.5 millimole HCl and 1 millimole H2M or maleic acid. No? So, ganun lang yung solving. Basta ang process lang dito kapag acid-base mixture, gagawin nyo, alamin mo lang gano'ng karaming ml na gamit dito, gano'ng karaming ml na gamit doon. Okay? So, for you to correctly label the volume for titrant, the volume of titrant for each titration processes, no? Kailangan alam mo that for diprotic acids, kung gano'ng karami yung second endpoint, gano'ng karami yung titrant na gamit dito sa second endpoint, ganun din sa first endpoint, no? Kaya in-emphasize ko yung last time. So, kung 10 ml na gamit to reach the second endpoint, that means 10 ml yung ginamit to reach the first endpoint for the diprotic acid. Tapos yung sobra dito sa 25 ml, kay HCl yun. Okay? Kasi 15 plus 10 is 25. No? So, yan yung 25 ml na nagamit sa first endpoint. Then, on the second endpoint, 10 ml na lang kasi ito na lang yung present. Ito na lang yung tinatitrate natin. Tapos, ipag-add mo na lang yung volume. So, 15 ml ginamit for HCl, 20 ml ginamit for maleic acid. To get their moles, gamitin mo lang yung equivalence equation. So, ginamit natin sa, sa number 1 is mole HCl equals 1 mole KOH. NaO pala, sorry. Okay, 1 mole NaO. Ang ginamit natin sa second process ay ito naman. Again, take note, 1/2 na siya. Hindi na siya 2. Okay, so I explained that already kanina. And hopefully, ay naliwanagan na tayo. Okay. Kasi usually nagre-reflect ako pag gabi. Okay. Kaya madalas gabi ako nagme-message sa inyo. Binabasa ko yung notes ko. Nahanap ako ng problem sa mga notebook ko, sa mga reviewer. So nakita ko, bakit 1/2 nilalagay ko dito? Sulat kamay ko yun. So, dapat hindi ako mali nun. Kasi 1/2 nakalagay. So yun, inaalala ko ulit, oo nga, 1/2 pala yun. So, I corrected myself na. Okay. So, hopefully, naliwanagan tayong lahat dun. Okay? So, again, instead of writing whole number 2 or 3, kailangan fraction yung ilagay. So, yan. So, this is the acid composition. The mixture of acid. Ito yung composition niya. 1.5 millimole for HCl and 1 millimole for H2M. O suppose, kunwari gusto hanapin yung molarity, kailangan i-divide mo to sa volume of the analyte, no? The initial volume of the analyte. Ang problem dito, wala naman kasi sinabing volume yung analyte natin. Ang binigay lang na volume is the titrant eh. So, di natin pwede makuha yung molarity. Okay? O let's say, kunwari, 25 ml yung mixture natin. You will divide this by 25 ml and you will divide this by 25 ml to get the molarities. Okay tayo doon? So, ganun lang. Yun lang yung pasikot-sikot dyan. But for now, millimoles lang. Okay? So, expect a similar problem sa quiz, no? Ang papalitan ko lang talaga is itong mga concentration, pati itong mga volumes, no? But the process, as you see, ganun pa rin. Ganun lang naman yung process, okay? So again, the mixture of strong acids, the acid mixture is quite unusual. Okay, so hindi ito masyado ginagamit because wala naman siyang application sa totoong buhay. Okay, walang application 'yon sa totoong buhay, no? Wala masyado. Okay, so ano yung may application talaga sa totoong buhay? Ito, yung base mixture. Okay, bigyan ko kayo ng daily products that contains mixture of bases, no? An example nun. Bigyan ko kayo example, yung sabon natin, no? Yung sabon, minsan sodium hydroxide and carbonates yung nakalagay doon. Okay? So, minsan gano'n yung nakalagay doon. Sodium hydroxide and carbonates. Sa liquid detergents, gano'n din ginagamit, no? So, mixture ng bases yon. So, as analytical chemists, no? Sila yon kasi hindi naman ako nag-work sa lab, no? So, them as analytical chemists, if they want to determine the concentration of the constituents of that detergent powder, then they analyze it using this concept naman, the base mixture titration. Okay? So yan. Ito yung mas may application kaysa sa acid, no? But the idea is same pa rin, no? So if you have strong bases, for example, NaO, KOH, no? They will only give one endpoint. No? Isang endpoint lang bibigay nila because again, same yung same lang naman yung pH at their endpoint, no? Which is 7. Kaya iisa lang yung titration curve dyan. Pero kapag meron kang weak bases na malaki yung difference sa Kb, then possible na dalawang titration curve ma-observe mo. Okay? So you have the first endpoint for the first base and the second endpoint for the second base. Okay? So yun. Parang sa acid lang din, no? Kapag malaki yung difference ng K value, pwede mag-split yung titration curves, no? Maghiwalay yung inflection points. So yun. So there could be multiple inflection points when the K values are big enough, no? Malaki yung difference, or 1,000 yung factor. 10,000 rather. Next one, if you have a strong base and a monoprotic base, no? Medyo magkaibang endpoints mo observe natin dyan. Bakit? Kasi yung strong base, ang inflection point niyan is sa pH 7. Okay? And sa weak base, ang inflection point niyan ay nasa pH below 7. Okay? So, ibig sabihin, may ma-observe tayo at pH 7 and may ma-observe tayo at pH below 7. So, ibig sabihin nun, dalawang endpoints meron tayo dito. Okay? Pag diprotic base naman, ganun din. Okay? So, ganun din yung concept dito sa diprotic base. So, sabay manuneutralize yung strong base and the first dissociation for the weak diprotic base. And then, to follow na lang yung second neutralization niya. Okay? So, dalawang endpoint din dito. Okay? So, yun yung mangyayari sa atin. For strong base and diprotic base, parang kanina lang din sa acid, no? So, sabay mag-neutralize yung strong acid, pati yung first dissociation, ganun din sa base, no? Sabay man-neutralize yung strong base, pati yung first dissociation ng base. Then, to follow na lang yung second dissociation. Okay? So, same concept lang din sa acid, no? So, again, saan ginagamit to? Application. Ito. So, this is the application analysis of carbonate and bicarbonate mixture. Okay? So, saan to ginagamit? Sa detergents, no? Detergent powder. Kasi kami nung undergrad namin, experiment namin to eh. Sabi sa amin, bumili kayo ng detergent powder, alamin yung components, no? So, bumili kami Ariel, bumili kami ng Ariel, Champion, ng Breeze, no? Parang maglalaba kami noon sa classroom eh. Ang bango-bango eh. Okay. Kulang na lang detergent, 'di ba? Pati damit, no? So, ganun ginawa namin noon sa lab, no? Kuha kami ng mga detergent powders, then we analyze the components using this concept. Okay? So, ito yung mga possible components ng ating ito yung possible component ng ating detergents, no? We could have sodium hydroxide alone, sodium carbonate alone, pwede rin naman sodium bicarbonate alone, or mixture of the two, no? So, ano yung mga possible combination natin? Pwedeng NaOH lang, okay? Pwedeng NaCO3 lang, pwede rin namang combination of the two, no? So, pwedeng carbonate and sodium hydroxide, kaya pwede namang carbonate and bicarbonate, no? So, ibig sabihin, there are 5 possible combinations sa ating detergent. Pwedeng sodium hydroxide lang yung nandun. Pwedeng sodium carbonate lang nandun. Pwedeng sodium bicarbonate lang nandun. O kaya, these two. Okay? Ang daming options, no? Okay. So, ang daming options na pwede meron yung ating detergent. So, it could be 5 of these, no? Any of these, no? Ano lang daw yung hindi possible? This one. Yung sodium hydroxide pati sodium bicarbonate, no? So, ito yung medyo hindi daw possible yung process na to. Yung paghaluin mo yung dalawang yan. Ang explanation dito is that, ganito. Yung OH na to, it could react with the H, no? So, manoneutralize agad yan. Okay? Kapag pinaghalo mo yung dalawang yan, manoneutralize silang dalawa. So, hindi sila talo. No? Hindi sila pwede paghaluin. Okay? Because the H here and the OH there could be neutralized, no? Against each other. Kaya hindi daw sila pwede paghaluin. Ang mga pwede lang paghaluin ay yung mga binox ko sa taas, no? So, ayan yung mga possible components ng liquid detergent, powdered detergent, no? Liquid soap, no? Powdered, wala palang powdered soap. Solid soap, no? So, ito yung mga components niya. Nung nagpagawa ako ng sabon sa student ko, sa organic chem tutorial class yan, nagpagawa ko sa kanila ng sabon. Sodium hydroxide ginamit namin. Although, pwede rin yung ibang to. Okay? Depende sa company. Kung nagko-cost cutting sila, ano? Ayan. So, pwedeng gumamit sila ng ibang substances. Okay. So, ano mo observe natin kapag we have combinations of this, no? So, ano yung mga ma-observe natin? Pag tinitrate natin yan, ganito. We use double indicators, no? Gumagamit tayo ng PHP and BCG. Okay? PHP, again, that's phenolphthalein. BCG, bromocresol green, no? So, in order for us to analyze yung contents very well, no, para malaman natin kung ano yung components ng ating mixture, kailangan i-monitor mo anong volume magkakaroon ng changes for the PHP endpoint and the BCG endpoint. Alamin mo kung anong volume siya magkakaroon ng transition for these two indicators. Ano purpose ng PHP indicator? to identify if there are inflection points at the basic part. Okay? So, that is pH 7 and above. No? So, ano ba yung nanoneutralize doon? Ito yung mga strong bases. Okay? So, yun yung ma-observe natin doon. Ang purpose naman ng BCG is to observe whether there are um, whether there are titrations that are neutral not ay nabubulol ako. Whether there are titrations that are neutralized at pH below 7. Okay. So yun yung purpose, but dalawa yung ating indicator dito. So to check whether may neutralization at pH above 7 and to check whether there are neutralization at pH below 7. Okay? So yun yung gagawin natin dito. And other than checking kung may changes sa taas and sa baba, no, sa pH above 7 and pH below 7, you should also monitor the volume kung saan nagkakaroon ng color changes. Okay? Kailangan i-monitor mo rin yung volume bukod sa color change. Okay? So, ganito. Let's start with sodium hydroxide. For sodium hydroxide, as I told you last time, pag strong base yan, mahaba yung inflection curve. Okay. So, sa sobrang haba ng inflection curve, when it reaches the PHP endpoint, marireach niya rin yung BCG endpoint color change. No? Kasi super haba niyan ng inflection point. So, parehas niya yan matatamaan at the same volume. Okay? So, anong meaning nun? Kunwari, nag-titrate tayo. If we observe that at one specific volume, yung dalawang color change nangyari, sodium hydroxide meron tayo. Okay? So, yun yung idea doon. Kapag iisa lang yung volume, pero dalawang endpoints yung nangyari, ibig sabihin, sodium hydroxide yung meron tayo sa ating sample. Okay? Bakit sabay sila mangyayari? Bakit sabay mangyayari yung color change for the two endpoints? Kasi nga, so super haba ng inflection point. No? Super haba ng inflection point na ma-observe mo talaga sila all at once. Okay? So, yan. So, all at once mo sila ma-observe. At, for example, 10 ml, nagbago yung dalawang kulay. Ibig sabihin nun, sodium hydroxide agad yung content ng iyong sample. Okay? Kasi nga, sa super haba ng inflection point niya, parehas niya natatamaan yung color changes na yun. Okay? So, yun. So, yun yung ma-observe natin kapag nao lang yung meron tayo. Okay? Both of them will be, change colors. Tas iisa lang yung volume ng titrant na ginamit for that. Okay? So, yun. What if sodium carbonate naman? Okay. So for sodium carbonate, dalawa yung endpoints nun. Okay. So one is on the basic pH, the other is on the acidic pH. So ibig sabihin nun, may ma-observe tayong color change sa basic muna, followed by the color change in the acidic. No? So mauuna muna yung basic, followed by the acidic. No? So hindi na siya sabay, kasi dito sabay isang volume lang pero sabay nag-color change. Dito, pag sodium carbonate, hindi. No? The first volume, yung phenolphthalein muna magbabago. If you added the same exact volume, yung bromocresol green naman yung magbabago. Okay? So again, kunwari 10 ml to, 10 ml din dapat to reach that. Okay? So exact dapat yun. Kunwari 5 ml to, edi 5 ml dapat yun. So, dun mo mamamonitor, dun mo masasabi that the compound contains sodium carbonate. No? If you observe two endpoints and then yung spacing ng dalawang endpoint volume ay equal. Okay? So, kunwari 10 ml to, dapat 10 ml din yun. Yung spacing nila ay equal. Okay? So, kapag ganun yung na-observe natin, we have a sodium carbonate solution. Pag sodium bicarbonate naman, okay, so this is a very weak base, so that's why it doesn't have any color sa phenolphthalein indicator natin. Kasi weak base lang to, no? So mababa siya dito sa color change ng phenolphthalein. So, ibig sabihin, kapag may bicarbonate solution ka, patakan mo ng pHP, walang kulay doon. Walang kulay. Kasi as you can see dito sa ating titration curve, di siya dadaan doon eh. Hindi siya dadaan sa color change nun. Ibig sabihin, patakan mo man yan ng patakan ng pHP, ibuhos mo lahat ng pHP, walang mangyayari. So you will not expect any color change sa pHP indicator. San lang? Sa BCG. Okay? Because when you titrate bicarbonates, the endpoint is acidic. No? So, dito ko lang maka-observe ng color change, not here. No? Again, because bicarbonate is a weak base. Hindi siya dadaan doon eh. Okay? So, ibig sabihin, from ano yung pwedeng kunin nating concept dito? Depending on the, kung sino yung mauna sa color change, and depending on the volume, volume of the titrant used, no? Pwede mo malaman kung ano components mo. Kunwari, at a particular volume, parehas nag-color change. Ibig sabihin nun, I have sodium hydroxide agad-agad, no? Kunwari, 5 ml, nagbago lahat. Ibig sabihin nun, sodium hydroxide lang meron ako. However, kunwari, at 5 ml nawala yung phenolphthalein color. Then at 10 ml, yung BCG naman nagbago ng kulay. Ibig sabihin nun, I have a carbonate mixture. I have a sodium bicarbonate solution. Sodium carbonate solution. Okay? Mauuna muna yung pHP mawala. And if you added the same volume of the titrant, pag nagbago yung kulay ng BCG, ibig sabihin nun, sodium carbonate yung tinatitrate mo. Pero kunwari, nagpatak ka ng phenolphthalein, wala pa rin talagang color. Ibig sabihin nun, bicarbonate agad meron ka. No? Patak-patak ka ng phenolphthalein, ayaw talaga magbago ng kulay. Binuhos mo na lahat ng phenolphthalein, wala talagang color. Most likely, bicarbonate meron ka. Okay? Bicarbonate ang meron ka. Okay? So, yun yung explanation dito sa curves na to. So, kapag iisang volume pero dalawang color change nangyari, nao agad yon. Pag dalawang volume, equally spaced out sila. Kunwari, 5 ml to, 5 ml yon. And at each volumes at endpoint, isa-isa nagbago yung ating indicator. Ibig sabihin, you have sodium carbonate. Pero kunwari, naglagay ka pa phenolphthalein, wala talaga nagbago. Tapos nung nag-titrate ka, yung BCG lang yung nagbago. Ibig sabihin nun, bicarbonate meron ka. Okay? So, yun yung idea lang dito. Depending on the volume of the titrant used and the color changes, pwede mo malaman kung ano yung meron ka sa solution. Okay? Ito naman, yung mga combinations. Explain natin yung combination. Na-explain natin to ha. So, let's explain this. Bakit ganyan yung titration curve, no? So, if you have a base mixture, kunwari sodium hydroxide and sodium carbonate, o kaya sodium carbonate and sodium bicarbonate, no? So, if you have a base mixture, sabi nga natin, dalawa yung endpoints nun most likely. Especially kapag may diprotic base ka, di ba? Dalawa endpoint na ma-observe mo. So, ibig sabihin, may phenolphthalein color change and meron ka ring BCG color change. No? However, you should keep in mind yung volume. Okay. Keep in mind nyo yung volume. Bakit? Kasi kapag sodium carbonate lang meron ka, kung gaano karami yung volume to reach the first endpoint, ganun din karami to reach the second endpoint. Okay? However, if you have a mixture, hindi equal yon. Hindi equal yon. O kunwari, eto, 25 ml, tas yung next endpoint, 5 ml. Ibig sabihin nun, other than carbonate, you have another component, no? Okay, kunwari 5 ml to, then dito 20 ml. Ibig sabihin, there is something else pa in your solution. Kasi sabi natin, pag carbonate lang meron ka, kung 5 ml tong first endpoint, 5 ml din yung second endpoint. Pero hindi eh. Ang nangyari dito, 20 ml to kunwari, tapos ito, 5 ml. So, ibig sabihin nun, there's something more in our mixture. Okay? Ibig sabihin, mas marami tayong strong base kaysa sa second endpoint na. Or kaysa sa second dissociation. Okay? So, yun yung idea. Kapag mas marami kang volume of titrant used at the first endpoint, ibig sabihin, mas marami kang strong base, no? Okay. Pag mas maraming volume at the first endpoint, ibig sabihin, mas marami kang strong base, no? Ibig sabihin nun, ang component mo ay yung strong base, no? You have the sodium carbonate and sodium hydroxide. Parehas yan strong eh. Kaya ang dami mong magagamit initially. Okay? So kapag na-neutralize na yung sodium hydroxide, pati yung sodium carbonate, ano mangyayari? Itong sodium carbonate, magiging bicarbonate yan. O yun, onti na lang magagamit mo. Kasi onti na lang yung bicarbonate na matitira sa solution. Okay? Para lang dun sa acid kanina, di ba? Yung sa example natin dito. Okay? So parang ganito lang din yon. Ang dami mong ginamit at the first endpoint. Then pagdating sa second endpoint, onti na lang. Bakit? Kasi you have a mixture of of a strong acid and your first dissociation. Ganon din dito. Ganon din dito. You have a mixture of a strong base and the first dissociation. Kaya super daming titrant ang nagagamit at the first equivalence point. Okay? Eh what if baliktad naman? Yung first equivalence point 5 ml lang. Tapos yung sumunod na equivalence point, 20 ml. Kunwari ganun, no? Yung unang endpoint naman yung onte, yung second endpoint yung super dami. Ano components ng mixture mo? Pag ganun daw yung case, you have sodium carbonate and bicarbonate. Okay? So, mangyari dito sa first endpoint, yung carbonate mo, ma-convert into bicarbonate. Then, on the second process, you have a bicarbonate from the carbonate and the other present bicarbonate in the solution. No? Okay? So, ganun. So, dalawa na yung bicarbonate mo na present dito. So, ibig sabihin, madami-dami ka talagang itatitrate to reach the second endpoint. No? So, ganun lang yung idea. So, kapag equal, let's say 5 ml, 5 ml, sodium carbonate lang meron ka. Pero kung nagbago yung volumes na yan, kunwari ito, 15 ml to, so ito 5 ml, there's something else. No? Kapag mas marami yung volume to reach the first endpoint, ibig sabihin yan you have a mixture of sodium hydroxide and sodium carbonate. Pag mas marami yung second endpoint kaysa sa first endpoint, ibig sabihin you have a mixture of sodium carbonate and sodium bicarbonate. So, ganun yung idea. So, in summary, ganito siya ina-analyze, no? Pwedeng double titration. So, kunwari ako magta-titrate, tas yung partner ko sa lab, yung magta-titrate pa na isa. Ako sa phenolphthalein, tas siya sa bromocresol. Kunwari ako, na-reach ko, 5 ml sa akin, tas sabi ng friend ko, nung nagta-titrate, 10 ml siya. Okay, so ibig sabihin nun, sodium carbonate meron ako nun. Kasi I need 5 ml to reach the first endpoint, and siya, kinailangan niya ng another 5 ml to reach the second endpoint. So, ibig sabihin, yung tinatitrate namin ay carbonate, sodium carbonate lang. Pero kung magkaiba na yung volumes namin, then ibang combination na yung pwede. No? Okay, so pwedeng double titration yan, dalawang tao yung magtatitrate. Okay? So, iisa yung sample mo. Yung isa magtatitrate for phenolphthalein indicator. Then yung isa magtatitrate to bromocresol color change. No? Tapos, i-compare nyo yung volumes nyo. Okay? Then, pwede rin naman double indicator. You have one flask. So, papatak mo muna yung phenolphthalein. Then, to follow yung BCG, the bromocresol green. No? So, pag pinatak mo yung bromocresol green, saka ka magtatitrate ulit. Okay? So, yan. So, pwedeng double titration or double indicator. Pares ako magbibigay ng example for the two. Okay? So, yan yung ginagawa namin to analyze the components. No? Pag double titration, yung isa magpi-PHP indicator, yung isa BCG. Then, you compared your volumes. Then, kapag double indicator naman, ikaw lang mag-isa gagawa niyan, no? PHP muna, followed by the BCG. Okay. And again, take note that depending on the volumes needed to reach the PHP and the BCG endpoint, depending on the volumes, you can infer ano yung components ng solution mo. Okay? Ang pwede mo malaman ano yung components ko. Okay? So by just identifying ilang color change nangyari at kailan sila nangyari at what volume sila nangyari. Okay? So to summarize whatever I said earlier, andito yun sa table. Okay, yung dinidiscuss ko is the double titration. No? So kunwari, ako, tapos yung friend ko, nag-titrate kami ng solution. Tapos iisang endpoint namin, iisa yung volume endpoint namin. Tapos yung indicator namin, parehas nagbago. Okay? Ibig sabihin nun, may component is sodium hydroxide. No? Kasi sabi ko kanina sa inyo, pag iisa lang yung volume na na-observe nyo, then dalawang endpoint yung nagbago, dalawang indicator yung nag-color change, that means sodium hydroxide talaga component niya. Okay? So for double titration, kung gano'ng karami yung phenolphthalein volume, ganun din dapat karami yung BCG. Okay? So yan. Paano naman kapag sodium carbonate? No? Kunwari ako sa PHP, tas yung friend ko sa BCG, no? Indicator. So ako naka 10 ml na ako. Okay, naka 10 ml na ako ng titrant. Then nag-color change sa PHP. Tapos kunwari yung friend ko naka 20 ml na, dun lang nagbago yung kanyang BCG. Okay? So ibig sabihin nun, sodium carbonate yung tinatitrate namin. Kasi gano'ng karami yung volume ko na nagamit to reach the endpoint. Okay? So gano'ng karami? Okay? So kunwari 10 ml. Then siya to reach the to reach yung endpoint niya another 10 ml. So ibig sabihin nga nun so ibig sabihin nun sodium carbonate yung nasa solution namin. Okay? So parang ito lang no. Kunwari 10 ml sa akin, then siya 20 ml ano sabi ko? Kunwari 10 ml sa akin, then siya na observe niya 20 ml. Ibig sabihin nun 10 ml dito and another 10 ml to reach the 20 ml. Ibig sabihin nun, sodium carbonate yung tinatitrate namin. Okay? So, yun lang yung idea dito. Okay. So, kapag 2 times, no? Kapag yung volume ng BCG ay pag kinalahati mo equal sa volume ng phenolphthalein, ibig sabihin nun, sodium carbonate yung tinatitrate niya. Okay? So, kunwari, 10 ml ka dito, tas 20 ml siya sa BCG. Divide mo yun sa 2, 10 ml yun, no? Ibig sabihin, 10 ml equals 10 ml. So, ang tinatitrate nyo ay sodium carbonate. Ito naman, sodium bicarbonate. Ano mangyayari dito? Kunwari, ako sa phenolphthalein, yung friend ko sa BCG. Patak ako ng patak ng phenolphthalein, wala talaga nagbabago. Wala akong color na nakikita. Ibig sabihin nun, zero yung volume ng titrant na magagamit ko kasi wala akong color eh. Okay. So, ibig sabihin nun, lagpas na ako sa phenolphthalein indicator. So, ibig sabihin nun, bicarbonate agad yung tinatitrate ko. Kahit anong patak mo ng phenolphthalein, wala ka talaga makikitang color. Ibig sabihin, bicarbonate solution meron ka. Bicarbonate lang. Tapos yung friend ko, nung nag-titrate siya, may certain volume siya nakuha. Ibig sabihin nun, bicarbonate nga yung ina-analyze namin. Okay? So, ito yun. Patak ako ng patak ng indicator, wala akong nakikitang color. Ibig sabihin, wala akong species na basic. Tapos yung friend ko, nung nag-titrate siya, dun lang lumabas yung color change. Ibig sabihin, bicarbonate meron siya. So, ito yan. Okay, if you have a mixture naman, okay, so ito pa rin yung idea, no? Mas marami pa rin gagamitin for the phenolphthalein indicator compared to the BCG indicator. Okay? So, yan. So, ito yung equation natin to identify whether anong species meron tayo. Mas marami kang gagamitin sa phenolphthalein indicator kaysa sa BCG indicator. Bakit? Kasi, mas marami kang strong base eh. Ano yung strong base dito? Yung carbonate, pati yung OH. So, mas marami ka talagang itatitrate to reach the first endpoint. Then, yung second endpoint, onti na lang. Okay? So, if you have a sodium carbonate and sodium bicarbonate naman, mas marami kang itatitrate to reach the BCG endpoint. Okay? Kaya ganito yung itsura dito. Mas maraming kakailanganin mo na volume for the BCG endpoint kaysa sa PHP. Kasi mas marami kang bicarbonates dito eh. Other than this, eto ma-convert pa to bicarbonate at the second endpoint, di ba? Okay. So, yun. So, kaya ganun. Mas maraming volume of titrant needed to reach the BCG kaysa sa PHP endpoint. Pag double indicator naman ganito mangyayari, you have the same flask. O, ako na lang to. Okay? So, pag nag-titrate ako, kunwari, ito, sodium hydroxide, nag-titrate ako, naglagay ako phenolphthalein, tapos nag-color change. Tapos nung pinatak ko yung BCG, nag-color change din siya agad, no? Instant yon. Pag instantly, nagbago yung pag instantly, nagbago yung BCG indicator mo without adding any titrant, ibig sabihin nun, nao yung constituent mo. Okay? So, yung PHP, nung pinatak ko na yung BCG, nagbago agad yung kulay, wala pa akong ginagawa, nagpatak lang ako ng BCG. Ibig sabihin nun, nao yung component ko. However, kunwari, sodium carbonate, nag-PHP ako, 5 ml. Then, naglagay na ako ng BCG indicator, then I added another 5 ml. Nagbago na yung kulay ng BCG. Ibig sabihin nun, sodium carbonate meron ako. So, medyo similar siya dito, no? Yan. Sodium carbonate. Nagpatak na ako ng PHP. Wala talagang kulay. Nagpatak ako ng BCG, then titrant, doon nagbago yung kulay. Ibig sabihin nun, bicarbonate lang meron ako. Okay, so for mixture, ganun pa rin naman, no? Mas marami kang magagamit na titrant for the PHP kaysa sa BCG kapag sodium hydroxide and sodium carbonate yung mixture mo. And then, mas marami kang magagamit na titrant kapag ganito yung component mo, bicarbonate and carbonate. Mas marami kang volume of titrant needed to reach the BCG than the BHP. Okay? So ito, same lang sila ng concept na. Ano lang talaga yung kailangan mo gawin dito. Alamin mo kung anong volume yung nagamit mo. Okay? Alamin mo kung anong volume ng titrant na gamit mo to reach the PHP and the BCG endpoint. Alamin mo lang. Then look at this table. Hindi naman necessary kabisado to, no? So look at this table na lang. Kung look at this table and apply the necessary equations. For example, ito kailangan mo i-divide pa by 2, no? So kapag equal sila, pag ito dinivide mo by 2, ibig sabihin ito yung component mo. So ganun lang, identify the volume for the PHP and the BCG endpoints, and then apply the necessary equations in the table. Then dun, pwede mo malaman yung components. Okay? So bakit ganyan yung equations natin? Andito kasi sa titration yung explanation. Okay? So papansin nyo, parang magkaiba yung sinabi ko dun. No? Not really, no? So same lang sila dito sa binigay kong concept dito. Don't worry, onti lang naman ganitong problems. So, isasama kasi nila to sa finals, kaya kailangan ko i-discuss. No? Kaya ayan, dinidiscuss natin siya. Okay, so let's try this first problem. A 10-gram sample containing mixed alkali and other inert components, okay, was dissolved and diluted to 500 ml water. Okay. A 25 ml alico was titrated with 14.35 ml of 0.1202 molar HCl to reach the PHP endpoint. And another 25 ml of the titrant is used. Ay, hindi. Ano pa? Ang sabi pala dito, another 25 ml alico. Okay? So, another 25 ml alico was titrated to the BCG endpoint and 38.5 ml yung titrant na nagamit. Identify the components and the percent weight of each. No? So, paano yan? O ganito. Ano nangyari sa problem? Basahin natin carefully. Second sentence tayo. Okay. So, ano sabi sa second sentence? So, dito sa 500 ml sample niya, kumuha siya ng 25 ml. Orig sample. So, dyan sa original sample niya, kumuha siya ng 25 ml, nilagay niya sa Erlenmeyer flask. Okay? Tapos ang ginamit niya ditong indicator ay PHP. Ang nagamit na volume ng titrant ay 1435 ml. So yun yung sinabi niya sa second sentence. Pagdating ng third sentence, ano sinabi niya? So ganun pa rin, kumuha na naman siya ng isa pang 25 ml. So kumuha uli siya ng 25 ml dun sa original solution mo. And then ang ginamit niya ay BCG. Okay, BCG ang ginamit niya. And naka-use yun ng 38.5 ml titrant. Okay. So ganito yung idea dito. So nag-prepare muna siya ng 500 ml solution. Okay, so 500 ml yan. Then dun sa 500 ml, kumuha siya ng 25 ml. And PHP indicator ang ginamit niya. And then another 25 ml for BCG indicator. So anong type ng titration tong ginawa natin? Is it a double titration or double indicator? Pag double titration, dalawa yung nagtatitrate. Okay? Pag double indicator, isa lang yung nagtatitrate. No? So ano yung nangyari dito? Dalawa yung nagtatitrate. Yung isa sa PHP, yung isa sa BCG. Okay? So yung isa nagtatitrate sa PHP indicator, tapos yung isa naman nagtatitrate sa BCG indicator. So ibig sabihin, this is a double titration. Okay. Pag nabasa nyo sa sentence, dalawang beses siya nag-titrate, no? So, yung isa sa PHP, then yung isa sa BCG, double titration yan. Okay? So, we need to use the following equations to identify whether ano yung components natin dyan, no? Okay? So, yan. So, na-identify natin that is a double titration process. Kasi dalawang beses siya nag-titrate, PHP, tas yung isa sa BCG. Okay? So, ano gagawin natin dito? Diba alam natin yung volume of PHP needed. And alam natin yung volume ng BCG needed. Let's compare them. Ipag-compare natin yung volume PHP and volume BCG. Okay? So, pag-compare natin sila. Okay? And then from comparison, by comparing them, we can get this. Kung ano yung constituent na meron tayo dito. Okay? So let's do that. Sulat ko to sa next slide. 1435. Ano yun? 38.5. Okay, let's compare the two volumes. Okay. So, sabi dito, if equal yung PHP and BCG, nao yung solution natin. Are they equal? Equal ba yung volume nila? Obviously, hindi. 14 to, ito 38. So, ibig sabihin yan, wala tayong nao. Hindi siya nao lang. No? Kasi hindi natin na-meet tong equation na to. Kasi sabi, kapag nao yung inyong constituent and double titration yan, kung 14 ml to, dapat 14 ml din yan. Which is not our case. So, X yan. So, hindi nao yung component natin. Ibig sabihin, 4 na lang. Sige. Sodium bicarbonate. 0 ba yung volume ng PHP? Hindi. 14 eh. Ibig sabihin, mali agad to. No? So, X agad to. Bakit? Kasi kailangan 0 to. Kaso 14 yun eh. Sabi sa problem eh. Ibig sabihin, X agad din to. Okay? So that means we are left with three other possible components na lang. Okay? So tatlo na lang yung options natin. Either ito yung meron tayo, ito, or ito. Okay? So gagawin natin to know kung ito ba tayo, ito, or ito. Gagawin natin, divide natin 2 by 2. Okay? Ano yung 1/2 BCG, volume ng BCG? Divide na lang natin yan by 2. So, 38.5, divide natin yan sa 2. 1925. Okay. Let's compare that, no? Ito yung volume PHP. Ito yung 1/2 volume BCG. So, sino mas malaki? Yung 1/2 volume BCG. Ito yung mas malaki compared sa PHP. Okay? So hanapin natin aling component yung equivalent doon. Yung mas marami pa rin yung kalahati ng BCG kaysa sa PHP. Ano 'yon? Ito. Ito yung case natin. Na kahit i-divide mo sa 2 yung BCG mo, mas malaki pa rin siya kaysa sa PHP. That means our component is sodium carbonate and sodium bicarbonate. Okay? So, yun yung idea. No, yun yung idea natin. So, kahit i-divide mo yung BCG by 2, mas malaki pa rin siya kaysa sa PHP. Ibig sabihin yun, your component is this one. Yun yung kwento nito. Kahit i-divide mo to sa 2, mas malaki pa rin siya kaysa dito. Ito yung component mo. Carbonate and bicarbonate. No? So, this is our mixture. Okay? So, yun yung sinasabi ko na aalamin mo lang yung volume, then apply the proper equations. No? Kunwari, ito 14 ml, ito 14 ml. Ibig sabihin, ito yon. Kunwari, ito 0 ml, tapos ito 38. Ito yon. Pero, in our case, ito 14 ml, ito 38.5. No? So, ito, divide mo by 2, mas malaki pa rin to kaysa dito. So, that means, ito yon. Mas malaki pa rin to kaysa dito, kahit i-divide mo to sa 2. So since that's our case, we have this solution. We have a component of carbonate and bicarbonate. Okay? So yan. So yan yung component natin. So anong component ng ating solution? We have sodium carbonate and sodium bicarbonate. Ayan, so alam na natin yung component niya. Ano na lang kulang? Na-identify na natin siya. Yung calculation na lang ng percent weight, no? Doon na lang tayo magkakatalo. No? Solving na tayo. So, paano yung solving neto? Katulad lang din ng kanina. Okay? So, we now know our, alam na natin yung ating, alam na natin yung ating components. No? So, pwede na tayo gumawa ng map ulit. No? So, i-map natin yung titration curve. No? So, yung sodium carbonate, 2 beses yan itatitrate. So, we will have sodium bicarbonate. And then after that, yung last endpoint, neutral. Ayusin ko yung sulat. Tanggalin ko na yung sodium, ha? So, yung carbonate muna, then dagdag ka acid, magiging bicarbonate yan. Then dagdag ka pa acid, tapos na yung titration mo. Okay, 2 beses ka magdadagdag ng acid. So, dito, dagdag ka acid, you will reach the first endpoint. Dagdag ka uli another acid, you will reach the second endpoint. Okay? So, yan. So, ito yung sa carbonate pa lang. How about the bicarbonate? No? Saan mo ilalagay yung bicarbonate? Eh di syempre, align mo yon kung nasan yung bicarbonate. No? Then, dagdag ka titrant, you will reach the end. Okay? So, ito yung first process. Ito yung second process. Okay? So, yan. Ito yung nangyari sa ating titration. Okay? So, yan. So, the PHP indicator, ano yung purpose uli ng PHP indicator? To identify the first endpoint, no? So, alamin natin yung first endpoint dito. So, yun yung purpose ng purpose ng PHP indicator, to know the first endpoint. So, ilang ml ng titrant ginamit to reach the first endpoint? 14.35 ml. Okay? So, yan. So, 14.35 ml of the titrant is needed to reach the first endpoint. Okay? And the volume of titrant to reach the second endpoint overall is, anong volume yon? 38.5 ml, di ba? 38.5 ml. So, dito, 14.35 ml. this point, 38.5 ml. Okay. So, yun yung idea. Ngayon, ipag-subtract natin tong dalawang volume ng endpoint to reach, to know kung gaano karami yung na-consume dito. Okay. Ito kasi gusto natin, gaano karami na-consume dito. So, ipag-subtract mo lang yung dalawang endpoint to know how much volume is added. Okay. So, ipag-subtract natin yan, 38.5 minus 14.35. So, 24.15 ml. Okay. So, ibig sabihin yan, so, nung na-reach na niya yung first endpoint, 1435, nagdagdag pa siya ng 24.15 ml to reach the last endpoint. No? So, ito, ganito karami yung titrant na dinagdag mo to reach the second endpoint. No? Giving us a total volume of 38.5 ml titrant used. Okay. So, ito, 1435. Then, to reach the second endpoint, you use 24.15 ml. Saan ang galing to? Ipag-subtract mo lang yung dalawang endpoints, yung BCG pati PHP. Pag-subtract mo lang sila. Okay? So, yan. Medyo mahirap na. Ganun talaga. Okay. So, the first endpoint, saan yan nagko-correspond? O, dito lang sa process na yan. Kasi ito lang yung process natin dito eh. Okay. So, the carbonate to bicarbonate conversion. So, 1435 ml na gamit dyan. 14.35 ml. So, kung 1435 ml yon, that means itong second process ay 1435 din. Okay? 1435 ml din yon. Kasi sabi nga natin, pag diprotic yung acid mo, kung gaano karami yung ml to reach this, ganon din karami to reach that ml. Okay? So, kung 1435 ml lang kailangan mo dito, saan yung sobra dito? Saan gagamitin yan? Dito. Okay? Yung sobra, dito yung gagamitin. Okay? Sa walang volume pa, no? Okay? So, gano'ng karami yung sobra? O, pag-subtract natin, 24.15 minus 1435. O, pag-subtract lang natin yung dalawang sobra, that means 9.8 ml ang kinailangan para dito naman. Okay? So, yan. Yung parang ginagawa lang din natin kanina, ginagawa natin dito, no? So, alamin mo kung gaano karami yung ml neto. So, kung gaano karami yan, ganun din sa kabila. Okay? Then, yung sobra, edi ilagay mo sa other species, no? Sa isa pang process. Doon mo siya i-carry over. Okay? So, ganun mangyayari sa atin. Alamin mo kung gaano karami to. Kung ilang ml yan, ganun din sa kabila. Then, yung sobra dito sa kabila na ml, dito yon mapupunta. Okay? So, now, we have identified gaano karaming titrant ang nagamit. No? Gaano karaming titrant yung nagamit. Okay? So, yan. So, alam na natin gaano karaming titrant nagamit sa ating solution. Okay? To neutralize this and that. So, i-add up na natin yung volume. So, the volume of titrant needed to neutralize the carbonate is 14.35 times 2 lang. 14.35 plus 14.35. 28.7 ml. So, ganyan karami yung ginamit for this one. However, for this one, for the second process, gano'ng karami? Di 9.8 ml. Okay? So, yan. So, yan. Na-identify na natin kung gano'ng karaming titrants ang nagamit to titrate carbonate and the bicarbonate. Kasi yun yung components natin, carbonate and bicarbonate. So, kinailangan natin ng 28.7 ml to neutralize this. And we needed 9.8 ml to neutralize this. Overall, that's 38.5 ml. Okay? So, given the volumes of our titrant needed to neutralize each sample, okay, we can now solve for their mass, no? Okay, so pwede na natin ma-solve yung kanilang mass. Paano? Paano yun? Yun yung ginagawa natin kanina. Mole A equals mole B. Okay? So since diprotic to, meron diprotic dyan yung carbonate, maglalagay tayong 1/2 no, sa isang species. No? So yan. Pag na-identify mo na yung volume, babalik ka uli sa equivalence equation natin. Katulad ng ginagawa natin earlier. Okay? Let me erase this part. Okay? So let me erase this. No, alamin muna natin yung moles. No? Moles muna bago tayo mag-mass. Okay? Moles muna. Ng carbonate and ng bicarbonate. So let's write the corresponding equation. Ano ginamit na titrant? HCl. So ilang HCl kailangan to neutralize the carbonate? Dalawa. Okay. Kaya nga 2 steps yan eh. Okay. Ang bicarbonate naman, isang HCl lang kailangan to neutralize that. Okay. Neutral. So let's set up the equivalence equation. Daming nangyayari, no? So we have the mole carbonate equal 1/2 mole HCl. Okay, so ito na yung equation natin. Again, ito yung correction natin. Instead of writing the 2, you write the fraction. No? Sa species na may coefficient na 2. So instead of writing 2 here, we write 1/2 mole of HCl. Okay, how about on the other side? Ganun din. HCO3 equals mole HCl. O monoprotic lang yan, so 1-to-1 lang yung coefficients nila. Okay, so let us now solve for the moles of the carbonate and the mole of the bicarbonate. No? Let's express the mole of HCl as molarity times the volume of the titrant used, which is nakuha natin kanina. Okay, so yan. I need more space dito. Equals 1/2 molarity HCl, volume HCl. Okay. Dito muna tayo mag-focus. Ano yung molarity ng HCl? Ayan. 1/2 times 0.1202 molar times the volume of the titrant used to neutralize the carbonate, which is 28.7 ml. Ilang moles ng carbonate meron tayo? Millimoles rather. And that's 1/2 times 0.1202 times 28.7. So we have 1.72487 millimole of carbonate na. Kopyahin nyo na yung lahat ng numbers para hindi tayo mag-round off. O ilang moles ng bicarbonate meron tayo? That is molarity HCl times volume HCl. So 0.1202 molar times ilang volume yung nagamit to neutralize this. Sabi natin kanina 9.8. Pasensya na, medyo mahirap talaga tong topic na to ha. Kaya onti lang ilalagay ko na ganito. Pero isasama kasi daw nila to sa finals eh. Kaya sige, turo natin. Kasi mahirap talaga to. So we have 1.17796 millimole. Okay? So ayan, nakuha na natin yung millimoles. No, ayun na. Okay? So nakuha na natin yung millimoles ng ating substance. Okay, so yan, nakuha na natin yung millimole ng ating substance. Then, ano susunod? Pwede na ba natin yan i-convert to percent weight? Pwede na. Pwede na tayo tumuloy doon. However, ito, may another, ano na naman dito, however. Okay, so since alam na natin yung moles ng ating species, may however akong dagdag, no? Ano yun? Ganito. Ang inanalyze lang natin ay 25 ml ng 500 ml, no? So we just analyze a portion of the original amount, no? Ibig sabihin nun, ano? So, portion lang din. Etong mole ng carbonate na to, etong millimoles na to, that only represents 25 ml of the whole, no? Ang gusto natin malaman is yung whole, no? Yung original amount, no? Okay? So, kasi ang nagawa natin dito is ganito. Again, 25 ml lang yung tinitrate natin. So, it means etong moles na to, ito lang yung katumbas nun, 25 ml lang ng alico. Saan ba galing to? Sa 500 ml. So, gagawin natin is that, ganito. I-scale up natin to. Scale up meaning, kasi onti lang neto yung kinuha natin. No? So, parang portion lang neto yung kinuha natin. And we analyze na ito yung amount nila. Kung gusto mo kunin yung original, alamin mo by what factor yung yung dilution natin dito. Okay? Kasi kumuha lang tayo ng kumuha lang tayo ng 25 ml ng original. Okay? So that means yung ating moles is a portion of the original lang. Okay? Portion lang siya ng original. So to correct for that, no? Kasi yung portion lang yung nakuha natin na to. To correct for that, no? We have to multiply it by the dilution factor. Okay? DF or dilution factor. So again, when we say DF, dilution factor yan. Okay? So ano yung equation natin dito? So this is the volume original divided by the volume alico. Again, so dilution factor, volume original over volume alico. Ano yung original volume natin? 500. Tapos yung alico natin, yung kinuha natin, 25 ml lang. So ibig sabihin, ang dilution factor natin ay 500 divided by 25. 20 times, no? Okay, so 20 times siya. So ibig sabihin, itong mole ng carbonate, pag times 20 mo yan, makukuha mo to, yung moles dito sa original mo. Okay? Kasi this one only represents this. Yan yung nasa 25 ml lang. If you want to get the 500, scale up mo yon. I-times 20 mo yon. Okay? So, yun yung concept ng dilution factor. Kasi ang inanalyze mo, ito lang. Ang gusto mo, ito yung original mo eh. So, kailangan ibalik mo siya doon. Okay? So, if ang ratio natin dito is 20, that means you have to multiply the moles by 20 to get the original moles of your species. No? So, kailangan natin i-multiply by 20 yung moles. No? Scale up. No? Scaling up tayo. Okay? So, since we are scaling up, times 20 natin yung moles natin. Okay? So, we say here the original moles. Mahirap talaga yung topic na to, ha? Pasensya na, ha? Kailangan kasi siya isama sa finals kasi sabi nila. Kaya i-discuss natin. Mahirap talaga siya. Kaya wala tayong magagawa. Okay. So to scale up, no? Scale up. Okay. So to scale up, we multiply the moles we calculated by the dilution factor, no? Para makuha natin yung original moles sa 500 ml solution. So let's multiply this by 20. Ito. 1.72487 times 20. Ilang moles yon? 34.4974 millimoles. Okay? So, ganito karami talaga yung moles sa 500 ml. No? Okay. How about the bicarbonate? So, that is 1.17796 times 20. So, we get 23.5592 millimole. Okay? So, yan. So, bakit ulit tayo nag-scale up? Ang purpose ng scaling up is kasi yung inanalyze mo, ito lang. Gusto mo yung original eh. Ito yung ina-analyze mo talaga dapat, no? Hindi naman kasi kasya to sa Erlenmeyer flask, kaya onti lang kinukuha natin. Okay? So, ibig sabihin, if you want to get the original amount, you multiply this by the ratio of the two. No? So, kunwari, 1 millimole to. Ilang millimoles katumbas nun in 500 ml times 20. Okay? 20 millimoles. Ang ganun ginawa natin dito. Okay? So, we scaled up our moles kasi nga, portion lang kinuha natin. Okay? So, yan. Ang daming nangyayari, no? Mas okay pa yung nakaraang calculation. Ganun talaga, no? Pasensya na. Kailangan to isama, no? Kaya medyo mahirap talaga to. Sorry. Okay? So, yan. So, you have to scale up kasi portion lang yung inanalyze mo. Okay? So, we now have the original moles, no? Ito na talaga yung original moles. Malapit na tayo matapos. Okay? So, nakuha na natin yung original moles by scaling up our sample. Okay? By accounting for the dilution factor. So, yan. So, since we now know the original moles, we can now convert them to mass, no? Always ba always ba tayo dilution factor? Hindi, no? Hindi naman. So, hindi tayo always magdi-dilution factor. Kunwari, walang sinabi na alico. Sa problem kasi na to, sinabi alico eh. Ibig sabihin, may dilution factor. Pero kunwari, walang sinabi, di kung ano yung nasolve mong moles, yun na yun, no? Pero kapag may sinabing alico, ibig sabihin, may dilution factor tayo. And the formula we use to determine the dilution factor is the volume original divided by the volume of the alico. Okay? So that is the formula we use to get the dilution factor. Okay? So, yan. So, nakuha na natin yung original moles by scaling up the previously calculated ones. And then we can convert this na to, we can convert this to grams and then later on percent weight, no? Okay? So, paano? Dito tayo, kunin natin yung percent weight ng carbonate. Ano yung multiply mo sa mole para maging mass? Di molar mass na lang. Okay? So, itong millimole, convert mo yan to moles na lang. Okay? Kasi multiply mo siya sa molar mass. Ang unit ng mole sa molar mass ay mole. No? Hindi siya millimole. So, you have to convert millimole to mole. That is by dividing it by 1,000. Divided by 1,000. So, we have 0.0344974 mole. Ano molar mass ng sodium carbonate? Sodium carbonate. Okay. Sodium carbonate, ha? Ano molar mass ng sodium carbonate? Google na lang natin. Wala akong periodic table ngayon eh. Sodium carbonate. Ang molar mass ng sodium carbonate ay 106 grams per mole. Round up ko na. Round off na. 106 grams per mole. Again, we are solving for the weight sodium carbonate na. So, yan. Ito sa numerator, we will get the grams sodium carbonate. To get the percent weight of the sodium carbonate from our sample, divide mo yun sa 10 grams. Yan yung sample natin eh, times 100 to get the percent. Okay, plug in na lang natin yung sa calcu. So we have 0.0344974 times 106 grams per mole divided by 10 times 100%. So the weight of sodium carbonate in our sample is 36.57%. Daming nangyari, no? Ayan. So yan na yung weight niya ng sodium carbonate sa ating sample. Okay? So that means if you have 10 grams of the sample, 3 grams doon ay sodium carbonate, no? Or 36% na ay sodium carbonate. How about the bicarbonate? Okay. So we are solving for the mass of the sodium bicarbonate, no? So to solve for the mass of the sodium bicarbonate, o dito na lang sa left side, sulat ko dito. 23.5592. To solve for the weight of the sodium bicarbonate, percent weight, sodium bicarbonate. So that is the mole of the sodium bicarbonate. Yung mole, yung millimole, convert mo sa mole by dividing it by 1,000. Divided by 1,000. Times the molar mass of the sodium bicarbonate. Google na lang natin. Sodium bicarbonate. That's 84. Ni-round off ko na ha. Ayan. So 84 grams per mole. Divide natin yan sa sample mass, which is 10 grams times 100%. You will get the percent weight of sodium bicarbonate equal to 0.02355592 times 84 times 100 divided by 10. 19.79%. Dami nangyari, guys. Okay. So, Ayan, tapos na tayo sa wakas. Isang problem pa lang yan. Meron pa mamaya. Meron pang isa. Pasensya na. Ang hirap, no? Pero ganun talaga. Anyway, ano nangyari sa atin? Ang nangyari sa atin is ang dami. Okay. So, una, ginawa natin is that we analyze the volume at PHP and BCG endpoint. No? So, since this is double indicator titration, we use this table to identify the species present. No? So, inalam natin at ito yung volume kailangan for PHP, ito yung kailangan for BCG. Okay, so since it doesn't meet the criteria for this and this, ibig sabihin, hindi yan yung components natin. Okay, kasi hindi niya na-meet tong criteria dito and dito. So, X tayo dyan. So, we are left with 3. No? So, of the 3, para malaman mo kung sino sila sa tatlong yan, you have to divide this by 2. No? So, since we knew that this is still bigger than this, even though it is divided by 2, so, ibig sabihin nun, ito yon. That corresponds to a mixture of carbonate and bicarbonate. Okay? So, ito yung mixture natin. So, yun. Sabi natin, yan. Ang solution natin ay gawa dito and ito. Ito yung mixture natin. So, that means this sample contains this. Okay? Then, using yung ginawa natin kanina dito, so, using this diagram, ginawa natin to kanina, di ba? To identify how much titrant is used to neutralize this and this, no? So, ganun din ginawa natin dito kanina, di ba? Binura ko na eh. Okay. So, yun. So, we determined how much volume ang kailangan for this to be neutralized and this. So, we found out that this, in order for this to be neutralized, we need 28.7 ml. For this one, 9.8 ml naman. And using the equivalence formula, we were able to get the moles of this and this now. Okay? So pag nakuha mo na yung moles nito, you check if may dilution na nangyari. Pag may nakita kayong word na alico, ibig sabihin may dilution factor tayo. Okay? Pag nakita nyo sa problem may alico, then you have to multiply the moles by the dilution factor. And again, what's the formula for dilution factor? Original volume divided by the alico volume. Okay, so that's 500 divided by 25 equals 20. So, ibig sabihin yung nakuha natin moles kanina, ita times 20 mo pa to represent the 500 ml solution. So, times 20 mo pa siya. Okay, kasi alico kinuha mo. May dilution factor yon. Pero kapag walang sinabi sa problem na alico, hindi mo na kailangan i-times 20. Okay? So, yun lang. In our case, we need to multiply it by 20. No? Para makuha yung correct moles sa original. So yan, nakuha na natin yung correct moles sa original. In order to get the percent weight, we just multiplied their moles by the molar mass of their salts. No? Okay? Yung mole ng carbonate, minultiply natin sa molar mass ng sodium carbonate. Yung moles ng bicarbonate, minultiply natin sa molar mass ng sodium bicarbonate. No? Take note of that. No? Kailangan yung salt form yung imumultiply natin ng molar mass. Then divided by the sample mass times 100, you will get the percent weight of our constituents in the sample. So we have 36% of carbonate, sodium carbonate, and 19% of sodium bicarbonate in our 10 gram sample. So ganun ginagawa namin pag detergent, no? Ganito kasi component talaga ng detergent powder. Ang inanalyze ko nun is Ariel. Medyo same dito yung result, no? Kaya ayan. Okay, so yan. Daming nangyari, no? Pasensya na, mahirap talaga siya. Kaya onting items lang gaganituhin namin sa finals. No? Don't worry, ako naman yung nagsasummarize ng ako naman yung nagko-compile ng questions sa finals. No? So mamomonitor ko kung gaano karaming ganitong question yung lalabas. No? Okay. So I will give more problems sa inyo, no, to practice para ma-try nyo naman yung iba't ibang constituents, no? Okay. Merong may dilution factor, merong wala, no? So, marami akong problems na ilalagay sa worksheet para mas ma-practice kayo. Okay? So, yun lang, ha? Again, pasensya na, ang hirap, no? Isa pa lang item na yan, ang daming oras na yung naubos, no? Kasi meron pang isa. Ano ba yan? Okay, ano ba yan? Ito, meron pa tayong isa eh. Okay. So ang na-describe natin sa problem na to is the double titration. Okay, kasi dalawang beses tayo nag-titrate, no, separately. Yung isa sa PHP, yung isa sa BCG. So this is a double titration process. Ito pa lang tayo. Okay, so for the second problem, I will give you an example on how to do this. Paano ginagawa to? Okay. So, similar pa rin yung process. Don't worry. Similar pa rin. Okay? So, let's read. Ito na yung last problem. Ito na rin yung last time na maghihirap tayo. Okay? So, a 1.2 gram sample containing alkali components is dissolved and titrated with 0.5 molar HCl to PHP then to BCG endpoint. No? Okay? So, ibig sabihin nun, yung sample na yan, tinitrate siya to PHP and BCG sa isang flask. No? So, ibig sabihin, this is a double indicator process. Iba yun sa double titration. Kasi kapag double titration, sasabihin dyan, eto, tinitrate dito. Then, another 25 ml was titrated to this. Double titration yun. Dalawa yung tinitrate mo. Dito naman, ita-titrate mo muna to PHP endpoint, then after nun, you add the BCG, then titrate. Dagdag ka lang sa vol flask mo. Okay. So this is a double indicator problem. Okay. The volume of the titrant consumed at PHP endpoint is 30 ml, while 5 ml was consumed to BCG endpoint. Find the constituents and percent weight. Okay. So yan. Okay. So ano yung kwento dito? Ganito. Visualize natin para mabawasan ang ating paghihirap. Visualize, drawing. You have Erlenmeyer flask. So, andyan yung 1.2 gram sample mo. So, tinitrate siya to PHP endpoint. Okay? So, ilang ml ng titrant dinagdag to reach the PHP? PHP endpoint. Ilang volume yon? 30 ml daw. Okay? Then, after nun, in the same flask, nagdagdag na naman siya ng 5 ml to reach the BCG endpoint. Additional 5 ml. Okay? To reach the last endpoint. With that idea, calculate for the constituents and the percent weight. Okay? Alamin natin constituent and percent weight. No? So, to know the constituents, same process. No? Same process tayo. Alamin natin, let's compare the volumes of BCG and PHP. No? So, pag-compare natin, sino mas malaki, Kasi kung sino mas malaki sa kanila, may corresponding constituent tayo doon. Okay? Given dito sa table na to. So, dito na tayo sa double indicator. O, lista muna natin yung volume. Lista natin. Okay? So, the volume needed to reach the PHP endpoint is 30 ml. For BCG naman, that is 5 ml. So, clearly, ang volume ng PHP is greater than the volume of BCG. Okay. So, clearly, yan yung ating case. Mas marami tayong PHP na gagamit, mas maraming volume ng titrant ang gagamitin to reach PHP kaysa sa BCG. Ano kaya yung component na to without looking sa table? The component is possibly sodium hydroxide and sodium carbonate rather. Sodium carbonate, no? Okay, bakit ito yung components natin? Kasi sabi ko nga sa inyo, pag mas marami kang nagamit sa mas marami kang nagamit na titrant for the PHP endpoint, ibig sabihin mas marami kang strong bases. Ano ba yung mga strong base? Edi sodium hydroxide and sodium carbonate, no? Ayan. Then para saan yung BCG? Kasi we know that kapag na-titrate mo na to, magiging bicarbonate yan, no? Yung sodium carbonate natin, magiging bicarbonate yan. So kailangan natin ng BCG doon, which is 5 ml lang. Okay? So if you look at the table to confirm, ito yun. So double indicator tayo. Mas marami sa PHP kaysa sa BCG. Okay? So confirmed, no, na ang components natin ay NaO and sodium carbonate. Bakit? Kasi again, bakit mas marami sa PHP kaysa sa BCG? Kasi nga mas marami kang strong species, no, strong base, no. Kaya mas marami kang magagamit doon kaysa sa BCG, no. Ito yung mga weak, no, such as bicarbonate, no. Okay, so ito yung ating component. Now, alam na natin yung component, so we were able to identify the component. So we say that ang component natin ay sodium carbonate and sodium hydroxide. Okay. So by just identifying the volumes, pwede mo malaman kung ano yung components mo. Now, gawa tayo ng diagram ng titration. O yung NaO, pag tinitrate mo yan, end na. Yung sodium carbonate, pag tinitrate mo yan, magiging ano yan? Magiging sodium bicarbonate. No? So yung sodium carbonate, magiging sodium bicarbonate, then after nun, end na. Okay. So this is the first endpoint. This is the second endpoint. Okay. So, ilang ml to reach the first endpoint? Sabi sa problem, 30 ml. So, we needed 30 ml to reach the first endpoint. And to reach the second endpoint, only 5 ml was used. Okay. So, since 5 ml na lang yung nagamit dito, ito, 5 ml lang nagamit natin dito, ibig sabihin nun, 5 ml din to. Okay? Kasi sabi nga natin, kung ilan ml na gamit mo dito, ganun din doon. Okay? So, kung 5 ml to, 5 ml din yan. So, ibig sabihin, dito sa 30 ml, yung 5 na gamit for sodium carbonate. How about the other 25 ml? Hindi kay sodium hydroxide na gamit yan. Okay? So, ganun lang. So, na-assign natin kung ano-ano yung mga volumes needed to neutralize our components. No? Basic logic lang yan. No? Kasi sabi natin, kung gano'ng karami to, ganun din karami to. Then yung sobra, pag ito, sinubtract mo dito, dun yun mapupunta. Okay? So, 25 plus 5, 30 ml. So, ito 5 ml. So, 5 ml lang. Okay? So, yun. Logic lang tayo dito. Kung gano'ng karami to, ito yon. Then yung sobra, lagay mo doon. Okay? So, that means the volume of titrant needed to neutralize sodium hydroxide is 25 ml titrant. And for sodium carbonate, that's 5 plus 5, 10 ml. Okay. So yan, alam na natin how much titrant are needed to neutralize this and this. So since alam na natin gaano karaming titrant na gamit dyan, we can now get the moles of this species. And then pag nakuha na natin yung moles niya, pwede na natin i-convert to grams and then percent weight. Okay? So same process pa rin. No? Sa una lang talaga to mahirap. No? Pagdating ng dulo, mahirap pa rin. No? Pero mas tolerable na. Kasi alam mo na yung steps eh. Okay? Kasi ulit-ulit lang yan, di ba? Alamin mo alin siya dito. Ganun yung process dito. Alamin nyo kung alin siya dyan. Pag alam mo na yung component, analyze paano yung titration process. Gawa kayo ng diagrams na ginagawa natin kanina. Okay? With those diagrams, alamin mo yung endpoints. No? Alamin mo kung how much titrant was used. No? And then, pag alam mo na yung titrant na ginamit for this and that, you can now solve for their moles. No? And eventually yung mass and percent weight. Okay? Ang problem is, may dilution factor ba tayo dito? Ano yung shortcut ko para malaman kung may dilution factor? May word na alico. Wala naman sinabi na alico dito. So, there's no problem. No? Wala tayong problema sa dilution factor. Okay? So, wala tayong problema sa dilution factor. That means, tuloy lang ang solving. Tuloy lang tayo sa solving. Ito, yung mole ng sodium hydroxide, yung mole ng titrant, convert natin to moles of the sodium hydroxide. No? So, monoprotic yan. So, we say mole ng NaO equal yan sa mole ng HCl. Kasi monoprotic yan. No? NaO is monoprotic, HCl is monoprotic. So, 1-to-1 yung ratio nila. So, to determine the moles of NaO, that is just molarity, HCl, volume, HCl. We have 0.5 molar times 25 ml, which is 25 times 0.5, 12.5 millimoles now. So yan, so we now know that NaO is 12.5 millimoles. No? How about sodium carbonate? About sodium carbonate. Dito tayo sa baba. Ano yung proper equation for sodium carbonate? That is 1/2 HCl. Again, ito yung correction natin. Instead of writing 2, you write 1/2. Okay. So, sinabi ko na bakit 1/2 yun earlier. No. Kasi, bakit nga ba naging ganyan yung equation natin? Kasi if you balance this correctly, this is the proper equation. Okay, so yan. So it will give off water molecule, carbon dioxide, and NaCl. Okay. Balancing chemical equation lang yan, ha? Ayan. So makikita nyo when you balance the chemical equation, ayun, you need 2 moles of HCl to neutralize carbonates. No? Tataka kayo, no? Ba't may carbon dioxide dun, sir? Ba't may salt, no? Na-discuss na yan ng in-org chem, no? Last sem. Sabi ko last sem, when carbonates are reacted with acid, they produce carbon dioxide gas. Okay? So, ayan. So, ayan. So, yung coefficient na 2 for HCl, gagawin mo siyang fraction pag nilagay mo dito. So, let's solve for the mole of sodium carbonate. So, that is 1/2 molarity HCl, volume HCl. So, 1/2, 0.5 times 10 ml. Okay? So, ilan yun? 1/2 times 0.5 times 10. So, that is 2.5 millimoles. Okay? So, since we now know the millimoles of carbonate and hydroxide, alam na natin yung millimoles nila, we can convert that to grams na. Do we have to multiply this by the dilution factor? Hindi na. Hindi mo na kailangan to i-multiply by the dilution factor. Okay? Kasi wala naman sinabi sa problem na alico. Kailan ka lang mag-multiply ng dilution factor kapag may alico. Okay? Kasi wala namang word na alico dito. No? Sana always ganun. No? Okay. So, yan. So, yan. Kapag wala sinabing alico dyan, edi as is na. Okay na yan. So, convert mo na natin to grams and then later on to percent weight. Okay? Let's do that. Note ko na lang dito sa taas. Okay? So, we now know that we have 12.5 millimoles of this and 2.5 millimole of that. Using those millimoles, gawin na natin yung grams and percent by weight. Percent weight, sodium carbonate. Sodium carbonate muna. Yun kasi yung una ko nasulat eh. Okay. So to solve for the percent weight of sodium carbonate, kunin mo yung grams of sodium carbonate divided by the gram of your sample times 100 na. Parang percent by mass lang din. Okay. Ginagawa natin yan since chapter 3. So familiar na tayo dun. So alamin natin yung mass ng sodium carbonate from the moles. That means you multiply this by the molar mass of the sodium carbonate. No? So 2.5 millimoles gawing moles. So divide by 1,000 lang yan. Times 10 raised to negative 3 moles. Times, ano yung molar mass ng sodium carbonate? Sabi natin kanina, 106 grams per mole. So itong numerator, this gives us the mass of sodium carbonate divided by the sample mass. So you have 1.20 grams. Then times 100 para maging percent. Okay? So ano sagot natin? 2.5 times 10 raised to negative 3 times 106 divided by 1.20 grams times 100%. So the percent weight of sodium carbonate is 22.08%. So, yeah. So 22% siya ng sample natin. How about the sodium hydroxide? Okay, so for sodium hydroxide, same process. Get the mass of sodium hydroxide. So that's 12.5. Yung millimole gagawing moles by dividing it by 1,000. Okay. So ito yung dinidivide by 1,000 times 10 raised to negative 3. What's the molar mass of sodium hydroxide? Google natin. Google na lang. Wala akong periodic table eh. Sodium hydroxide molar mass. 39.997. Gawin na natin 40. Round off na tayo. 40 grams per mole. Divided by the sample mass times 100. So that's 41.67. Okay, so yan. So a big proportion of our sample is the pwede pong 40. Yes, pwede naman 40 na lang. Kasi 39.997, di ba? 40 na lang. Okay na yun. Okay. So, yan. So, this is our percent weight for each constituents, no? Okay. So, yan. So, as you can see, no, sa umpisa lang siya mukhang mahirap, no? Kasi mahirap talaga siya, no? Pero, as you go on, ulit-ulit lang yung process, no? Ano yung process na ginawa natin na paulit-ulit? Alamin mo yung volume. Then from the volume needed to reach the PHP and the BCG endpoint, alamin mo kung anong component, 'di ba? O paano mo malalaman yung component? Ito, may table tayo. Okay? So, alam niyo naman kung kailan siya double titration o kaya double indicator. Pag sinabing double titration, sasabihin sa problem, on a separate or another was titrated with ganito ganyan. Pag may nakita kayong word na another, no, ibig sabihin double titration 'yon. So you apply the necessary equations to identify the species. Pero itong problem natin dito, sabi dito, then. Okay, may mga keywords tayo, then, no? Ibig sabihin after PHP, nag-BCG agad siya. Then yung previous problem sabi another. Okay? So yun yung mga keywords natin. Pag sinabing another, double titration yan. Pag sinabing then, yan, double indicator. Iisang Erlenmeyer flask lang yan. Okay? So once you know the components, ano gagawin mo? You determine paano yung changes sa paano yung changes sa molecules when you titrate them. Ang process ay ganito, no? Yung carbonates, magiging neutral agad yan. Mag-e-end agad yan. Yung carbonates natin, ay yung bicarbonates, mag-e-end agad yan. Okay? So, isang titration lang yan. End. Tapos na. Pero yung ating bicarbonate, dalawang beses yan. So, yung carbonate mo, magiging bicarbonate muna, then end. Okay? Kailangan ipag-match mo to. Okay? Pagpantayin mo yan. Okay? So, ganun lang naman yung paulit-ulit dito. Okay? So, kunwari, HCO3, end. Tapos, kunwari, carbonate component mo. And then, magiging bicarbonate yan, then end. No? Kung ilang ml ginamit dito, ganong ml ginamit doon. Then, kung ilan yung sobra dito, doon yun. Diba? Ganun ginagawa natin, diba? Paulit-ulit. Okay? So, ito yung typical scheme, ibibigay ko na, no? Bibigay ko na yung typical steps. Ang gagawin nyo na lang is identify the volumes correctly. Okay? Logic lang yan. Okay, so for sodium carbonate, the process is this, no? Carbonate, magiging bicarbonate, then end. Tapos na yung titration. Ito yung PHP indicator, ito yung BCG indicator. Tapos na yung titration. For bicarbonate, sodium bicarbonate, BCG indicator lang yan. Then end. No? PHP, BCG. Then tapos na. If you have a mixture of sodium hydroxide and sodium carbonate, ano yung mangyayari? Yung NaO, end agad yan. First endpoint, tapos agad yan. Neutralized agad yan. However, yung carbonate natin, yun yung 2 steps, no? Okay. So the first endpoint is the PHP. The second endpoint is the BCG. Then, ano yun na lang? Kayo na mag-assign. Kunwari, 5 ml to, 5 ml to. So, yung sobra, dito. Okay? 10 ml to. Ibig sabihin, 10 ml din to. So, yung sobra, dito. Okay? So, ganun. How about this one, the last one? We have the sodium carbonate, same process. Kulay blue. Ito, sinasummarize ko na para susundan nyo na lang. You assign correctly the volumes na lang, ha? Okay. Kailangan correct yung pag-assign nyo ng volume. Sodium carbonate. Oops. Ba't ang kapal ng ballpen? Wait lang. Naglolo ko yung pencil ko. Okay. So yan, HCO3. Then end. Then if you have a bicarbonate, ganun din. End. Okay. So ito yung PHP indicator. Yan yung endpoint niya. Ito yung BCG indicator. Yan yung endpoint. Okay. So ito yung scheme, no? Ito yung schematic diagram pag aalamin nyo na yung volume, no? Okay. So alam nyo kapag diprotic yan, kung ilang volume yung ginamit sa second endpoint, ganun din yung gagamitin sa first endpoint, no? And vice versa. Okay. Kunwari, 5 ml ginamit sa first endpoint. Gano'ng karami for the second endpoint? 5 ml din. Then yung sobra, ibigay mo sa kasama niyang species. Okay? So yan. So, basta alam mo na siya gawin, makukuha mo na yung total volume of the titrant needed to neutralize each constituents. Ipag-add mo lang, kunwari 5 to, 5 yun, edi 10 ml yung nagamit to neutralize this. Then yung natira, yun yung kay sodium hydroxide. Di ba? Ganun lang. Basta alamin mo lang how much titrant was used to neutralize each component. Once you know the volume of the titrant needed, you can now solve for the moles. No? Yung solving for the moles, ano lang yan? Yun yung sinasabi natin pag monoprotic, ano yan? Na equals NB lang. Pag diprotic, ito na yung may fraction, 1/2 Na equals NB. Pag triprotic, yan ay 1/3 Na equals NB. O yung may 1/2, yung may 1/3, yun yung kung sino yung may 2 na coefficient sa balance equation. Okay? Kung sino yung may 2 na coefficient sa balance equation, yun yung may 1/2. Kung sino yung may 3 na coefficient sa balance equation, yun yung may 1/3. Okay? Na-explain ko na bakit 1/2 and 1/3 na siya. No? Hindi na siya yung times 2 times 3. No? Sorry for that. No? Okay? Pero yun. So, since corrected na natin yun, we can apply it here. Pag nakuha mo na yung mole ng components mo from your titrant, check mo muna kung may dilution factor. Kasi mamaya may dilution factor. Paano mo malalaman kung may dilution factor? Pag may sinabi na alico, itong aliquot na yan, no? Alico. Pag may nakita kayong ganyan, ibig sabihin may dilution factor tayo. So in order for you to get the original moles, ano gagawin mo? You divide the original by the alico volume. Okay? So 500 divided by 25, we get 20. So, ibig sabihin yung moles na nakuha mo kanina, ita times 20 mo pa. Ano? Kasi, small portion lang ng original yung na-analyze natin. So, to get the original amount, you need to times it, you need to multiply it by 20 talaga. No? So, yan. That is if may alico na word. No? Pero kung walang alico, thank you Lord, tayo doon. Kasi hindi na natin paproblemahin yung dilution factor. Okay? And so malaking pasasalamat natin yun sa Diyos kapag walang dilution factor. Okay? So yan. Kapag walang dilution factor, yan, dire-diretso lang. No? Dire-diretso lang yung calculation. Pero kapag may dilution factor, you have to multiply the moles by that. No? Times 20, times 10, times 5. No? So ganun. Ganun gagawin nyo. Okay? Then, pag nakuha mo na yung moles talaga, including the dilution factor, if there's any, you can convert that to mass, no? To convert the moles to mass, you multiply it by the molar mass. Kung gusto mo ng percent weight, no? You divide the mass of the component by the mass of the sample times 100. Ganun lang, no? So, sa una lang talaga siya intimidating and alam ko ang daming na-intimidate, daming umalis no? Pero okay lang, no? Kasi hindi ko naman kayo mapipigilan, no? Pero ganun yung process, no? Ito na yung simplified version na matuturo ko talaga, no? Ito na yung simple yung version. Okay? Pag nanood kayo ng ibang channel din, ganun din naman kukwento nila. Okay? So, ganito din yung process nila doon. Okay? So, ibig sabihin nun, wala tayong magagawa. Ganito talaga siya. Pero, again, basic steps lang yan, no? Basic steps lang yan. Alamin mo yung volumes ng dalawang indicator. From that, identify the species. Once you know the species, ito yung mga corresponding equations. Then, from this equation, you get the volumes, no? Needed to neutralize each component. Okay? So, alam nyo na kung paano yun. Hindi ko na ulitin. Then pag alam mo na yung volume of titrant needed to neutralize each components, you use this. Okay? You use this equation to get the moles of this. Pag nakuha mo na yung moles nito, then, ano na? Pag nakuha mo na yung moles nito, pwede mo na yung multiply sa molar mass to get the grams. And if you divide that grams by the mass of the sample, you get the percent weight. And that's all. Yun na yun. Okay? So, ang mangyayari sa atin, tapos na tayo sa ating session today. So, salamat sa mga nagstay, no? Yan. Alam ko na intimidate agad kayo sa problem kasi mahirap talaga siya. Ganun talaga eh. Pero don't worry, I will give you more samples, no? Bibigyan ko kayo ng example for each of these, no? So, merong problem for this, merong problem for this, no? Merong double indicator, may double titration. Okay? So, I will give you 10 problems agad for this topic only. Hindi pa kasama yung earlier titration processes natin. So, anong purpose? Para ma-practice nyo talaga, no? Okay? Kasi, ang anakem practice lang talaga, no? Okay lang makalimot, pero once na maalala mo na siya, yun, tuloy-tuloy na yung process mo. Ikot-ikot lang yan eh. Alamin mo to, alamin mo to, alamin mo yon. Yun, tapos ka na. Okay? So, ganun lang. So, sa worksheet nyo, which I will upload maybe around Thursday na lang, no? Kasi, yeah. So, maybe Thursday ko siya ma-upload. Ang mangyayari sa atin doon is yun nga, isa-isahin ko sa inyo yung mga process. I will give a problem na ito yung process, double titration na nao, may double indicator na nao, double titration na ito, double indicator na yon, so on and so forth. No? So I will give problems like that para masanay. No? Okay. Pero anyway, onti lang naman yung ganito sa finals. No? I will assure you na onti lang yung ganyan sa finals. No? Ang marami sa finals ay ito, yung mga pH calculation. Okay? But still, we don't need to be hindi dapat tayo mapanatag, no? Kasi I still don't know kung ano yung mga ibibigay ng colleagues ko sa final exam. Nag-ano kasi kami doon eh, ambaga ng problems, no? So yan. So I still don't know kung ilang questions bibigay niyan. Pero I expect naman na mas maraming pH calculation. But still, there are problems like this. Kaya be prepared. No? So, ganun mangyayari sa atin. So, yung dalawang quiz natin, the first quiz will be pH calculations. Okay? The first quiz is the pH calculation only. So, gamay nyo na yon. Then, for the second quiz, that's this one, the analysis of carbonates and bicarbonates, including the indicators. Okay? So, yan. So, ganun yung mangyayari sa atin, ha? Okay. So, yung first quiz, puro pH calculation lang yon. So, yung previous knowledge nyo earlier, you can apply that. Pero yung second quiz, ito yung analysis of carbonate and bicarbonate. No? 2 attempts naman yun. No? So, malalaman nyo saan kayo nagkamali. No? Okay? Then I will add the, mag-upload din ako ng answer key for the quizzes, quiz 5 no? Quiz 5 part 1 and part 2. Para pagdating ng finals, expert na kayo. Okay? So yun na. Pasensya na, medyo mahirap talaga last topic natin. Pero that's life, no? That's anakem. Mahirap talaga to. But imagine nyo na lang na tapos na yung paghihirap natin after this topic. Okay? So saying electrochem, mas madali na yan. Okay? So yun na lang. Isipin nyo na lang yung bright side. After neto, madali na siya ulit. Madali na lang yung calculations ulit. Okay? So with that, no? Baka may questions kayo? Or kung gusto nyo magpa-clarify doon sa mga i-upload kong worksheets, no? Please don't hesitate to ask me, no? Mahirap kasi talaga tong topic na to. Kaya I encourage you to ask questions. No? Hindi porket mahirap ay susuko tayo. Or kaya mag-google na lang. Kasi I will make sure na yung problems, hindi siya mag-google. Kasi onti lang yung problems na ganito sa Google. Kaya ako talaga yung gagawa ng problem. Na. Kaya yan. So, yan. Don't hesitate to ask. Okay? So, yan. Mahirap pero kakayanin. Okay? So with that, I will see you again next week na lang because again, I will let us dedicate our Thursday and Friday for the quiz, no? Ang hirap 'di ba? Kaya I will give you that day na lang para mag-review, okay, and magsagot ng quiz. Okay? So again, pasensya na mahirap and take note of the correction I said earlier, no? And the new concept, the dilution factor. So yan. So with all those in mind, so we are done with chapter 5. No? So salamat na. Salamat at nagtiis kayo. Yung iba kasi natakot na ata. No? Okay. So sige. I'll see you again next week. So hopefully mataas scores natin sa exam this coming weekends. So, let's see you again. Bye-bye and stay safe. No? A copy of the video will be uploaded on YouTube, no, for your reference. Okay. So, yun lang. So, bye-bye and kain na tayo ng lunch. Pasensya na, ang tagal ha. Bye-bye.